to take 7 very different people with 7 different personalities, strengths and weaknesses, and all come up and put a patch together, it takes some work. We did come up with one, and we're very happy with it. We actually had the help of a friend and a co-worker here, Mike Santee, and he came up with a very nice idea for us, and we went ahead and put it together.
The crew arrived in their T-38 training aircraft from the Johnson Space Center in Houston, Texas. This is a standard operation for the crew to come in about 3 days before launch. Their arrival was again at about 3:30 p.m. Eastern Time. Flying in the lead T-38, of course, is the commander, Andy Allen. And he, flying in the back seat, is one of our astronauts from the Italian Space Agency, Umberto Guidoni. Pilot Scott Horowitz arrived flying the T-38, and flying in his back seat is mission specialist Jeffrey Hoffman. Claude Nicolier is preparing to make his 3rd trip into space today. Maurizio Kelly, mission specialist, is making his 1st trip into space today.
We've been kind of busy coming across the Gulf here, but it's a beautiful day to fly, and we look forward to a day like this on Thursday afternoon so we can get back up and go fly again. This time it'll be on Columbia.
They are bundled up in St. Louis and Chicago. They're fending off yet more snow in New York. They're digging out from an avalanche in Utah. And school kids are riding a large yellow sled down the icy streets of Seattle. Weather's in the headlines again. It's been a recurring theme for the last 12 months.
The United States has the most active weather pattern in the world from the point of view of tornadoes, flooding, winter storms, and hurricanes. We are the #1 country in the world for receiving this type of weather.
Why does it have that dubious #1 ranking? Because of geography, climatologists and meteorologists say. They're meeting this week in Atlanta. The U.S. is flanked by 2 oceans. A gulf with warm, moist weather is just to the south, and the towering Rockies slice through it in the west. Together, they can create havoc with the weather. Consider the heavy rains and mudslides in California last winter. These after a near drought for the region. A few months later came the stifling heat wave in the Midwest that killed more than 500 people in Chicago alone.
The big difference that led to so many deaths in a region of upper Midwest was the fact that we had abnormally high soil moisture.
Wet soil and extremely high temperatures made for a virtual steam bath. Then came hurricane season, the 2nd most active on record.
We went 2 months or so continually writing advisories on one storm or another, and that kept us very busy, and we were looking forward to the end of the hurricane season.
The season ended in the southeast, but then hurricane-force winds slammed into the northwest in December. A month later in January came the great blizzard that shut down much of the eastern United States. Yes, meteorologists say this has been an unusual year, even for the United States. But fortunately, technology now enables them to better forecast the extreme weather. The blizzard, for example, was predicted a few days beforehand. That allows for better planning.
For the first time, I think you see a situation where the medical community is now being tied into the climate and weather forecasting community.
That, one would hope, would help keep the underdressed in warm shelters, the elderly out of their sweltering homes, and school buses off of dangerous roads. Brian Cabell, CNN, Atlanta.
Pech für Touristen, die vor dem Winterwetter in sonst so sonnige Florida flüchten. Statt der im Februar üblichen 20 Grad plus erwartet sie eine Temperatur von 5 Grad minus. Plantagenbesitzer bangen um ihre Zitrusfrüchte. Und auch die Erdbeerpflanzer befürchten enorme wirtschaftliche Schäden.
Für die Erdbeer- und Zitrusfarmer im südlichsten Staat der USA bahnt sich eine Katastrophe an. Das Einzige, was ihnen bleibt, um ihre Pflanzen gegen die nächtlichen Minustemperaturen zu wappnen, ein Eismantel, hausgemacht.
Temperaturen in den USA lassen die Amerikaner zittern und die Touristen verzweifeln. Viele deutsche Urlauber hoffen in Florida eigentlich auf ein wenig Sonne, Strand und Meer. Doch nicht Badehose oder Badeanzug. Der Wintermantel ist zurzeit das passende Kleidungsstück am Strand von Miami Beach. Von dort berichtet Peter Klein.
So stellt man sie sich in Deutschland vor, die Strände Floridas, dem angeblichen Sonnenscheinstaat. Doch so sieht es derzeit wirklich aus. Der abgehärtete Rettungsschwimmer trägt Handschuhe, Liegestühle liegen verlassen da. Die Strandmeister von der Beach Patrol frieren einsam im Auto. Nein, rausgehen tue ich nicht. Und Katrin Jäger, aus dem fernen Darmstadt in ein ungeheiztes Hotelzimmer in Miami Beach gereist, muss sich fröstelnd fragen lassen.
Warum sind Sie nicht an die Nordsee gefahren?
Das frage ich mich auch bis jetzt immer noch.
Willkommen in Amerika, dem Land der Extreme, wo deutsche Urlauber frieren und floridianische Bauern um ihre 1,2 Milliarden $ schwere Obsternte zittern. Zitrusfrüchte mögen nun mal keinen Frost. Palmen auch nicht, wie der Inhaber einer Baumschule weiß. Nein, versichert sind wir nicht, das lohnt sich nicht. Ja, wenn es für die Urlauber das nur gäbe, eine Versicherung gegen Gänsehaut.
Ich friere ziemlich, ja.
Doch keine Angst, morgen wird's wieder wärmer.
Um 4:19 Uhr Ortszeit hob die europäische Trägerrakete vom Weltraumbahnhof Kourou in Französisch-Guyana ab. Wenige Minuten später setzte sie einen japanischen Telekom-Satelliten planmäßig im All aus. Es ist der 9. japanische Satellit, der von einer Ariane-Rakete in den Weltraum gebracht wird.
Remember back in the early days of the stealth program, when hardly anything was known about this aircraft? It could have looked like a flying saucer for all anyone knew, but those days of secrecy are long gone. In fact, now you can see a stealth just driving along. And a lot of people are learning to fly this F-117 at Holloman Air Force Base near Alamogordo, New Mexico.
It's a simple airplane to learn to fly.
Well, simple for you, maybe. Of course, rookies don't fly this craft. It's a fighter for captains and colonels, Air Force pilots with lots of experience with lots of other planes. But they still have to study, and study hard.
Our training in the United States is the best in the world.
Outside, about 50 stealth fighters await them, and off they go.
It is very comfortable. It's a very roomy cockpit. It's very much fun.
There are about 130 pilots here, and a lot of what they do is practice at nearby bombing ranges. This is how it looks from their viewfinders. And this, you may remember, is how the stealth appears during real bombing runs, like this one in Baghdad 5 years ago. But the pilots of the stealth fighters don't just practice bomb attacks, they also practice camera attacks. That's right, they fly over urban areas, taking pictures as part of navigational training. They can take pictures of individual homes, even backyard sheds. What do pilots have to say about flying these machines? Only good things.
You know, that sense of freedom that you get while you're airborne, and you know, being able to go upside down occasionally.
Is there anything you'd rather be doing?
No, absolutely not.
Of course, the Air Force doesn't show off everything about its F-117, such as the inside of the cockpit, but it has certainly come a long way since the days when some assumed that the stealth probably looked something like, oh, say, a flying saucer. Ann McDermott, CNN, Holloman Air Force Base near Alamogordo, New Mexico.
Hello and welcome. I'm Catherine Calloway. I'm in for Miles O'Brien. NASA prepares to launch a probe to the asteroid Eris in hopes of learning more about the origins of the solar system. Stay with us. Hot on the heels of the spectacularly successful Galileo mission to Jupiter, NASA's about to blast off on another voyage of discovery. This time, the destination is an asteroid called Eris, and scientists hope it could provide them with some clues about our solar system's distant past. Here's Ann Kellen once again with the details.
It's called NEAR for Near-Earth Asteroid Rendezvous. It's NASA's first mission to explore the surface of an asteroid. Equipped with solar panels, the probe is the size of a golf cart. It will carry an arsenal of monitoring and imaging instruments into space, traveling 1.6 billion miles over the next 3 years. The final year will be spent orbiting one of the closest asteroids to Earth, Eros. a rock about the size of Manhattan, named for the Greek god of love.
And NEAR, in fact, is going to give us the first really good close-up look at an object which may preserve materials dating all the way back to the origins of our solar system, to the time when the planets, including Earth, were first forming.
Scientists theorize that some asteroids are fragments of planets like our own that were smashed to bits soon after the solar system formed. Researchers have long thought a collision between Earth and an asteroid led to the extinction of the dinosaurs. Even though the asteroid Eros is not dangerously close to Earth, scientists say it's only a matter of 1 million years or so before Eros and Earth cross paths.
However, the size of Eros is such that it's actually even bigger than the asteroid that caused the end of the Cretaceous period and the end of the dinosaurs and all that. So if there were ever a collision, it would truly be a catastrophe. But it's not predicted at this time.
Within the last 5 years, the Galileo spacecraft has flown by 2 asteroids on its mission to explore Jupiter, providing quick flyby images of the asteroids Gaspra and Ida, which turned out to have its own moon.
Our camera will have a resolution 10 times better than Galileo could achieve. That's good enough to see a house or even perhaps a garbage truck, to give you a scale.
The NEAR mission will get within 10 miles of Eros' surface. In addition to sending back images from every conceivable angle, the probe will measure the chemical and mineral makeup of the asteroid. NASA plans to launch NEAR February 16th from Kennedy Space Center in Florida. Ann Kellen for CNN.
At the conclusion of the NEAR mission, the NASA researchers say they may attempt to land the probe on the asteroid. Arianespace, the European commercial space transportation company, hurled another communications satellite into orbit this week. Launched from the Guyana Space Center in French Guiana, the Ariane 44P rocket deployed the satellite for the Japanese company NNT. Business is booming for Arianespace. The company currently has a backlog of 39 satellites to be launched, with the next one scheduled for March 2nd.
Vorläufer für Weltraumfähre an Bord dieser selbstentwickelten J-1-Rakete haben japanische Wissenschaftler HyFlex ins All geschickt. Ein Versuchsflugzeug, das der Entwicklung einer eigenen Raumfähre dienen soll. Doch die Freude im Kontrollzentrum war verfrüht. Zwar ging HyFlex wie geplant im Pazifik nieder, versank dann aber unplanmäßig sofort in der Tiefe. Der japanischen Raumfahrtbehörde gingen dadurch wertvolle Testdaten verloren.
Der Start einer chinesischen Rakete mit einem amerikanischen Kommunikationssatelliten an Bord ist fehlgeschlagen. Die Trägerrakete vom Typ Langer Marsch explodierte nach nur 5 Sekunden. Durch herabstürzende Trümmer wurden etwa 10 Menschen verletzt. Die Live-Übertragung des chinesischen Fernsehens wurde sofort abgebrochen.
Unmittelbar nach dem Start explodierte eine Rakete, die einen US-Satelliten ins All bringen sollte. In der Nähe der Startrampe wurden mehrere Gebäude beschädigt. Über Verletzte und Tote gibt es keine Angaben. Das chinesische Fernsehen brach die Übertragung vor dem Aufprall ab. Die Rakete, deren Vorgängertyp im Januar 1995 ebenfalls beim Start explodiert war, damals wurden 6 Menschen getötet, hatte gerade eine 3-jährige Testphase hinter sich.
Bei dem missglückten Startversuch kamen gestern 4 Menschen ums Leben, mehr als 100 wurden verletzt. Die Rakete war 20 Sekunden nach dem Start explodiert. Die Trümmer stürzten auf die umliegenden Häuser. China hat sein Programm zur Beförderung von Satelliten unterdessen auf unbestimmte Zeit ausgesetzt.
Trägerrakete vor 2 Tagen ums Leben gekommen. Mehr als 100 wurden nach Angaben von heute verletzt. Die meisten von ihnen hätten giftige Gase eingeatmet. Andere seien von der Druckwelle oder umherfliegenden Trümmern getroffen worden. Die Rakete war kurz nach ihrem Start vom Raumfahrtbahnhof Xichang vom Kurs abgekommen und explodiert. Es war das 2. Unglück dieser Art innerhalb von 13 Monaten.
The tradition continues as we celebrate the achievements of African Americans. Kathleen Ellis takes us on a space-age adventure with an astronaut who remembers his roots.
10 seconds. Go for main engine start. Main engine's now started. Main engine's up and running. 3, 2, 1, and liftoff of Space Shuttle Discovery.
February 1995, Bernard Harris makes history. One of only 7 black astronauts, he is the first black astronaut to walk in space.
Just the end effector, yeah. That's good.
1 year later, as the U.S. celebrates Black History Month, Harris reflects on his accomplishment and looks to the future of space exploration.
To be the first was great. It really was. But to me, it signifies that there would be many more behind me. I like to use the term, the first of many that will be behind me. Not only other African Americans, but other minorities, other peoples of this country and other countries participating in this great venture.
For Harris, the experience was a high point of a journey that began years ago. From the time he was 8 years old, he dreamed of becoming an astronaut. On his way to his dream, he reached many other personal goals: pilot, flight surgeon, scientist, mission specialist. As Harris explains, his trip to the stars has its roots in history.
Black History Month is a time in which we recognize the achievement of African Americans in this country, and I think that we have made tremendous contributions. I think it's kind of ironic when we look at history itself and you realize that astronomy, the study of the stars, that whole origin started out being done by people from Africa, my forefathers. And now I get to fly amongst those same stars, and so I have a great sense of pride. I think personally that a people cannot advance, cannot move forward unless they know their history, unless they have a foundation to know where they have started. And if you don't know where you are and where you came from, you'll never know where you're going.
So where do we go from here?
Space is our future. Space technology is our future. Space and access to space is going to be tremendous. And it will start 2 years from now with the International Space Station. Here we'll take nations coming together to build an orbiting laboratory that will be used to further advance humanity. The result of that are going to be tremendous spin-offs in technology. And as space becomes more accessible, that's going to multiply the contributions that it makes to the development of this society. And if you're not a part of that, if you're not educated in that field, you won't have a job. Space will touch every aspect of life here on Earth.
While space exploration will have an impact on technology, the environment, and the economy, Harris says it offers much more. The view from space inspires a sense of universal community that stretches well beyond Black History Month.
You don't see any lines or differences and separations in the people on Earth. And I don't think there is an astronaut alive that didn't come back with a great sense of humanity.
A compelling reason to shoot for the stars. In Houston, Texas, Kathy Nellis, CNN Future Watch.
NASA has teamed up with the Japanese Space Agency to learn more about solar storms and the role they play in electrical blackouts and brownouts here on Earth. The two space agencies are using sophisticated computer software to analyze X-ray images of the sun taken by Yoko, a Japanese satellite. They hope their data will eventually lead to better solar storm forecasts. The solar winds are waves of electrified particles blown out toward the planets. The electrified particles bombard the Earth's atmosphere, disrupting power transmissions.
Sonde NIR. Eine Delta-Rakete brachte den 800 Kilogramm schweren Flugkörper von Cape Canaveral aus ins All. Die amerikanische Sonde soll bis 1999 Daten über einen Asteroiden liefern. Die Wissenschaftler erhoffen sich dadurch weitere Erkenntnisse über die Entstehung des Sonnensystems.
And we are just a few hours away from another launch of the Space Shuttle Columbia. This mission involves an international crew, 2 Italians, a Swiss joining 4 from the United States. The plan is to deploy an electricity-generating satellite on a tether or cord about 20 kilometers in length. A similar mission in 1992 didn't work. Joining us from the Kennedy Space Center in Florida now is Professor John Logston. He's director of the Space Policy Institute at George Washington University's Elliott School of International Affairs, also director of the Center for International Science and Technology Policy. Well, Dr. Logston, as you look out there and consider the fact that in a few hours there's going to be a lot of flame, a lot of fire, and for 10 years the Russian Mir has been in orbit, this is sort of a juncture in space history, isn't it?
It is indeed. This evening there are going to be 4 Russians, 4 Americans, 2 Italians, 1 Swiss, and 1 German in orbit. I mean, it's truly internationalizing space.
And it normally doesn't make the front page anymore, does it, unless something goes wrong?
No, and well, it's not supposed to. This is not any more romance. This is doing science and doing real work in space.
The work of this mission is similar to one that was tried before, that is the generation of electricity by sort of a gravity gradient process of getting something way out there on a tether. What does it, the magnetic field of Earth or what?
Well, it's like a traditional motor. I mean, this tether, which is a thin thing, 20 kilometers long, but not much thicker than our thumb, and you've got a 1-ton satellite at the end of it, is cutting through the Earth's magnetic field in the ionosphere and generating electricity, generating a form of matter called plasma. So there's a lot of science being done, plus testing this concept for future applications.
Is it a practical idea? Could you run a spaceship's lights on that?
It generates a fair amount of electricity. It's 5,000 volts at a half an amp, so I think that means 2,500 something. What's the next watts? And that's a fair amount of electricity.
Let's look at some of the other programs. Now, the Russians actually have been forced at times to delay launches because they simply lack the funding. And yet, the world is plunging toward privatization of the entire shebang, isn't it?
Well, on our side, we're going to privatize management of the shuttle. This is the 75th shuttle launch. We ought to know how to do it by now. And so a private contractor is going to take over preparing the shuttle for launch, but the payloads will still be largely governmental. And in Russia, Mir isn't one of the real foreign currency exchange assets of the Russian government. Both Europe and the United States are paying Russia a fair amount of hard currency for access to Mir.
All right, the Chinese have had with their Long March rockets some rather short walks, and this has been an unfortunate addition or subtraction from the China hopes, has it not?
Sure. Last week's launch accident in China was a real blow to their desire to be a player in the commercial launch business. I mean, this was a $200 million satellite that didn't get off the launch pad and caused apparently not only a lot of damage but loss of life.
And a satellite which was really owned and built in the United States, wasn't it?
Yeah, it was a Loral-built satellite. It was owned by Intelsat, which is an international consortium. So, again, space is an international undertaking, both in private and government terms these days.
Right, we've lost the political and almost warlike competitiveness, but we're still in, the world is still involved very much in a sort of commercial competition, isn't it?
Sure, as space becomes more and more mature, it's already a multi-billion-dollar business and growing at a fairly high rate. And so Europe, Japan, the United States, Russia, China are all competing for a share of that market. So we've gone from political competition to political cooperation, but added to that economic competition.
Do you foresee the day when the economic competition might eventually give way to economic cohesion of some sort? Is that such a socialistic thing to contemplate?
Yeah, I think as space becomes much more a normal part of our life in the 21st century, it'll be like any other place to do business. There'll be cooperation among firms across national borders, but still a fair amount of competitiveness.
Very well. As you prepare to watch the liftoff, have you seen a great many of them? Do you get a chance to do it?
I've been coming here. My first launch was Apollo 11 in 1969. So this is something that makes it all real when you talk about this stuff. Is to see people and machinery leave and go into orbit is really very exciting.
When you watch those fragile little characters getting aboard, and when you then feel the literal beat of the rockets on your chest, it makes space something different from that academic thing that's on the third page, doesn't it?
Indeed. I recommend the experience of coming down to a launch to anybody. It will never be routine again.
Very well, sir. Professor John Logsdon is the author, by the way, of The Decision to Go to the Moon, Project Apollo and the National Interest. He's professor of political science and international affairs at George Washington University, director of the Center for International Science and Technology Policy, and a man whose position right now is envied by a lot of people. Professor, thank you.
Thank you.
And the crew is on board. Liftoff of the Shuttle Columbia is scheduled in less than an hour. CNN International, of course, is planning live coverage.
Crew prepares to soar into space aboard a U.S. shuttle just minutes from now. The U.S., Italian, and Swiss astronauts will deploy a tethered satellite, sort of a satellite on a string. Our viewers in Europe and Africa break away now for Larry King.
The following is CNN coverage of a live event.
Hello, John Holloman at CNN Center. The Space Shuttle Columbia about to leave the Earth on a 2-week mission. This mission will last for 13 days and 23 hours. The main thing the astronauts trying to do, launch a satellite attached to the end of a long, long wire. It's called the tethered satellite experiment, and the last time it was tried, it failed when the tether wire caught on a bolt in the cargo bay and tangled. The wire is 12 miles long, and the crew will try to unreel it, so the half-ton metal ball at the end is orbiting 11 miles further out in space than the shuttle itself. 4 of the astronauts on board flew on the 1992 mission to launch the satellite. They've been training for 2 years to avoid the problems of that earlier trip. For the first time in NASA history, most of the 7 people on board Columbia were born outside the United States. Now then, we're going to listen in to the final few seconds of this countdown.
T-minus 15 seconds. T-minus 12, 11, 10, 9, 8, 7. We have a go for main engine. 5, 4, 3, 2, 1. And we have liftoff of the Space Shuttle Columbia, continuing space research through tethered satellite technology.
Roger roll, Columbia.
Houston now controlling. Columbia rolling on course for a 28.5 degree inclination orbit.
Gauge is showing 45% on the left. Roger, stand by. We're showing good output. Columbia, we're showing good engines, good commands on all 3. Okay, thank you much.
Good call with that. All engines operating well on board Columbia. Columbia's engines now throttling down to 2/3 throttle to prepare the spacecraft to pass through the area of maximum air pressure and go supersonic. Columbia's altitude 29,000 feet.
Confirming good engine throttle down and throttling up now. Okay, Houston, we copy that. It's just our bias on the TC gauge. And Columbia, you're go at throttle up. Go at throttle up.
3 engines on board now back at full throttle. The crew reporting a errant gauge on board. However, all indications for the engines are that they're operating well. Again, back at full throttle. Altitude now 69,000 feet. Downrange from the launch pad, 8 nautical miles. Columbia already traveling 2,000 miles per hour. Flight controllers standing by at 2 minutes after launch for burnout and jettison of the twin solid rockets.
The 2 solid rocket boosters, one attached to each side of the Space Shuttle Columbia, no longer attached. They're now falling back to Earth, to the Atlantic Ocean, where they'll be recovered sometime in the next 12 to 24 hours. The shuttle, well on its way into orbit, more than 160 miles above the Earth, in a 2-week mission to study how tethered satellites generate electricity and how science experiments on what will become the largest, or at least the longest, spaceship ever created by human beings, one that is 11 miles from one end to the other, operate in the microgravity of space. Looks like this launch is going very, very well. The shuttle will be in orbit in about 5 minutes from now. And at this point in the launch, we're going to rejoin our regular programming. For those of you watching CNN Domestic, we're going back to Talk Back Live. For those watching us on CNN International, back to the news. This is John Holloman, CNN reporting.
Astronauts lifted off into space just about an hour ago. Joining us now for a report on the mission is CNN's John Holloman. John?
Well, Lisa, you know, the most dangerous part of any space mission is the first 8 minutes, from the time they say zero and the thing leaves town to the time that it reaches orbit. This afternoon or this evening, depending on where you're watching us, that the countdown and launch went just perfectly. The International Spaceship was launched on schedule less than an hour ago for its 2-week space odyssey.
Liftoff of the Space Shuttle Columbia, continuing space research through tether satellite technology.
That's something beautiful. Beautiful weather for the launch. Now that the shuttle is safely in orbit, the 7-person international crew can get down to business, starting almost immediately. They're setting up housekeeping, and they'll begin to test the tethered satellite in the cargo bay. Starting first thing tomorrow morning, the satellite will begin operating in the cargo bay. It'll be released Saturday afternoon U.S. time for a 2-day trip, 20 kilometers above the shuttle. The crew will spend time steering the spaceship around to stop any oscillations in the tether connecting the payload to the Shuttle Columbia. This is an international mission, more than any previous shuttle launch. Here's the crew as they came out to get on board earlier today. The tethered satellite is made in Italy, and 2 astronauts, one from the Italian Space Agency, the other from the European Space Agency, are on board. There's also Claude Nicollier, the Swiss astronaut who has flown before on the shuttle. In addition, payload commander Franklin Chang Diaz is an American, but who was born in Costa Rica. There are 3 American-born astronauts, including the pilot and the commander. In a pre-flight news conference, the non-U.S. astronauts talked about the fact there would be a bunch of aliens aboard the shuttle. They got kind of a kick out of that. Highlights of the mission from here on include the release of the tethered satellite 2 days from now, the reeling in of this half-ton metal ball at about this time on Monday. Both those events very tricky, according to the crew members, because there's a possibility as they're letting it out and pulling it back down in that it could potentially hit the side of the shuttle and do some damage.
So this half-ton ball, how are they going to maneuver it so that they can stay safe?
Well, they have to see what the ball does first, really. So that's the problem. They don't know exactly what's going to happen. The first thing that they do before they release it is they build a tower. It's sort of a collapsible plastic tower down in the cargo bay that will lift the ball up, I guess 10, 12, 15 meters above the cargo bay. That should offer them some protection after they start letting this pencil, actually thinner than a pencil, toothpick size cable out with the ball on the end of it. They hope that will give them all the protection they need. This thing, as we say, will go out 20 kilometers, which is a long way out in space. This, if it works, will be the, if not largest, the longest spaceship ever put together in space at 20 kilometers from one end to the other.
And certainly this operation takes a lot of coordination and joint work. How were these astronauts trained? Were they trained together in the United States? Or
They started their training, all of them in their home countries, and then they've been in the United States for a couple of years getting ready for this mission. Normally, on a space shuttle, you have 2 teams of astronauts if you're going to try to do things around the clock. This time there are 3 teams, and the reason that there are 3 teams is to have one group that overlaps the other 2 just in case something goes wrong with this ball on a string. And the Italians and the Swiss speak their native tongues. The Americans know a little Italian. They know a little Swiss. Franklin Chang Diaz speaks Spanish as his first language, English as his second. And while they're working together, they all try to speak English. But if they slip into native tongue, the other guys can generally figure out what they're saying.
Well, we'll be watching. Thank you, John.
CNN's
John Holloman joined us live to tell us about the shuttle mission. Hillary, the crew will try to release a satellite weighing nearly 450 kilos on a tether, some 20 kilometers long. The experiment is planned for Saturday. Friday will spend preparing equipment for the dangerous and difficult mission.
Die 7 Astronauten der US-Raumfähre Columbia haben eine gewagte Aktion vorbereitet. Sie wollen am Samstag ein Experiment versuchen, das vor 4 Jahren gescheitert war. Ein Satellit soll an einem 20 Kilometer langen Draht aus der Ladebucht des Shuttles entlassen werden und 36 Stunden lang Strom erzeugen. Die Weltraumbehörden wollen damit Erfahrungen für einen elektrischen Antrieb im All sammeln.
Lancement parfait pour Columbia, qui débute ainsi une mission scientifique de 14 jours en emportant 7 astronautes en orbite, dont 3 Européens. Le but principal de cette mission, c'est l'étude d'un système tout à fait original. Un satellite véritablement tenu en laisse par la navette, comme un ballon, au bout d'un câble qui sera long de plus de 20 km. Quel est l'intérêt de cette délicate expérience ? Le câble du satellite est un conducteur électrique. Emmené par la navette, il va traverser le champ magnétique de la Terre et comme tout conducteur qui traverse un champ magnétique, il va produire un courant électrique. C'est le principe de la dynamo ou de tout générateur d'électricité. Ce serait donc une manière de produire de l'électricité pour les véhicules spatiaux ou les stations. Mais il pourrait servir aussi à la propulsion des vaisseaux spatiaux, puisque quand on alimente une dynamo en électricité, elle devient un moteur électrique. D'autre part, un tel système pourrait aussi servir de véritable ascenseur spatial et aider à remonter ou redescendre des satellites en orbite. Ou alors, placé sous la navette dirigée vers la Terre, il pourrait servir à explorer des couches de l'atmosphère qui sont autrement inaccessibles. Autrement dit, un tel système est véritablement plein de promesses technologiques. En fait, cette expérience avait déjà été tentée lors d'un vol précédent de la navette, mais n'avait pu être menée à bien à cause d'un malencontreux boulon qui bloqua très vite le déroulement du câble. Astronautes et scientifiques sont donc particulièrement désireux de réussir cette fois-ci. Tout a donc bien commencé pour ce vol important et samedi soir, les astronautes commenceront à déployer leurs satellites captifs. Ce sera alors le véritable début de la partie scientifique de cette mission.
Attempts to generate electricity in space come unplugged. NASA officials have been forced to further delay a tricky experiment in space for 24 hours. They had planned an attempt to generate static electricity using a most unusual generator. The satellite was to be extended 20 kilometers from the Space Shuttle Columbia by a tether, a task that failed in an attempt in 1992. Engineers have been working overtime to figure out what's causing problems with the two computers that control the experiment. So far, all that's been generated is a sense of frustration.
A series of computer problems prompted NASA to delay the release of a tethered satellite for 24 hours. NASA officials say all those problems appear to be resolved, so Columbia's crew now plans to release the satellite tomorrow afternoon.
Astronauts on the Space Shuttle Columbia are now ready for one of their more challenging assignments. Astronauts aboard the Space Shuttle Columbia say they are ready to take on their riskiest mission yet. On Saturday, NASA officials opted to delay the release of an Italian satellite because of computer problems. But the technical glitches have apparently been resolved, and in just a few hours' time, the astronauts will slowly reel out the satellite on a thin 19-kilometer-long tether. CNN's John Holloman has been following this risky shuttle mission and joins us now with the latest. John?
Cynthia, the big time for this is 2045 GMT. That's when this satellite will begin to leave the cargo bay of the shuttle for its mission of about 24 hours, way out in space. Life aboard the shuttle is a lot better today than the last time we talked. The astronauts have solved the problem with the computers, which caused much of their trouble when they were aboard the shuttle. And what they're doing, as a matter of fact, right now is they're beginning to take pictures outside of the Earth as it flies around below. This is the astronauts as they were just a couple of hours ago doing what they were doing. Also, out in the cargo bay, the tethered satellite is operating normally, and the equipment which will reel that satellite out into space seems to be working as well. We'll know a lot more about this deployment when it gets underway, starting in just a few hours from now. Again, here's sort of the time frame for how things are going. Here's how it works. A 38-foot, 12-meter boom will be extended from the cargo bay, starting at about 1840 GMT. It'll elevate the satellite high above the cargo bay. The satellite will start moving away from the shuttle, as we said, at 2045 today. It's dangerous because this satellite could oscillate back and forth as it's released on its 1/10 of an inch wide tether wire. Shuttle Commander Andy Allen will be at the controls, and he has the ability to precisely steer the shuttle out of the way to stop oscillations if they happen. The whole thing will take about 5.5 hours for the satellite to reel out to its full distance from the shuttle, much as 12.5 miles or 20 kilometers above the shuttle. Shortly after ground controllers looked at the satellite, they moved the camera over to the Earth so we could see the Sahara Desert this morning. There are a few clouds there, as you can see. The two astronauts from Italy, the country which made the tethered satellite, are on the flight deck right now, ready to help out during this deployment and step in if anything goes wrong.
There's also a Swiss astronaut on board, so truly an international flight.
Yeah, and one of the American astronauts was born in Costa Rica. This is the most international space shuttle mission that they've ever had. More people born in other countries than born in the United States. And as the astronauts have said to us over the past couple of months, they realize this is the wave of the future, because the International Space Station is still in the kind of the middling stages of construction. They're going to start putting it together in space in the next 12 to 18 months, and it's going to be a big time in space for the United States. But whereas in the old days it was the U.S. and Russia, now there are a lot of players out there, and the U.S. is doing what it can to get all the major players in its tent, including the Russians, to get the space station built.
John, let me ask you, the last time they tried this satellite on a tether was 1992, and it didn't work very well. Is that why they waited so long to try it again until they get the technicalities worked out?
That's part of the reason. They wanted to make sure it was going to work the next time for sure. Another reason is, you don't think of this, but the shuttle can only fly 7 or 8 times a year. And after the Challenger disaster, there was a 4-year shutdown. And a lot of people had a lot of things they had wanted to put on the space shuttle. So the what they called the manifest, their list of which flights go when, got really crammed up. There's still some scientists who have been working for 15 years on a project they thought was going to fly on the shuttle 5 years ago, which still hasn't flown. So it's just a very crowded cargo bay to put things, and a lot of, you have to, if you have a failure, you have to wait in a long line to get back in.
Let me ask you about the ability to generate power in space. I think those of us who saw Apollo 13 saw a mission where they were running out of battery power and running out of electricity while on the mission. Is it going to be considered important when you're building a space station to be able to generate power in space yourself?
Nothing up there works without electricity. You got to have lights, you got to have heaters because it's so cold out in space, and the best way to get those things is electrical. They haven't figured out a better way to do power than electric yet. And so they have solar panels. The problem with the solar panels is they can get hit by a meteorite or meteoroid and destroyed, and they degrade over time. So they'd like to have another way to generate electricity. This tether, now they say it may go out to 23, 24 kilometers, the full length of the wire. Just by moving through the Earth's electromagnetic field going around the Earth, electricity is generated. It'll go down this wire into the shuttle, and if it works the way they think it will, they'll be able to use something like that on the space station in addition to the solar panels and whatever else they come up with.
Great. Well, we will be following the story throughout the day, and you'll be back with us later.
Absolutely.
Thanks very much, John Holloman. World News will continue after this short break. Astronauts aboard the Space Shuttle Columbia say they are ready to take on the most dangerous mission yet. On Saturday, NASA officials opted to delay the release of an Italian satellite because of computer problems. But the technical glitches have apparently been resolved, and in just a few hours, the astronauts will slowly reel out the satellite on a thin 19-kilometer-long tether. After it is completely deployed, the crew will conduct experiments on generating electricity with the space tether. Scientists hope to prove such devices can be used to power spacecraft one day.
This is the time that the satellite is supposed to be released. We'll listen in to the next few seconds and see if we see any motion and see if we hear any commentary saying it has in fact been released. That's the problem with the payload bay camera.
On board, the crew's switched on the electric motors that...
We have motion. Flyaway looks nominal.
There is motion, and you can see it.
Copy.
If you look at the place where the satellite is connected to that, or was connected up until a second ago to that boom, you can see a big black spot growing larger as the satellite slowly moves out of its cradle. We have to apologize for this picture. I don't think it's our fault. I think it's NASA's fault.
Good for the satellite as it begins slowly moving away from the tip of the boom.
So far, as you can see, it appears to be moving straight up.
Just about 1/2 meter of tether out at this point. 1/2 meter en route to almost 13 miles.
Fine and clear, Dave.
An interesting thing about this is all done without any astronaut touching of the tether system itself. It was all done on the ground. The astronauts are watching it through the windows, although 2 of the astronauts are prepared to go out and conduct a spacewalk to rescue this in case the mechanical and computerized equipment that's doing it automatically somehow fails to do its job correctly.
1 meter of tether out now.
2/100ths of a mile
Satellite,
an hour.
Moving away from the boom at
we're not totally sure why.
about 12/1000th of a meter per second.
That's 12/1000ths of a meter. What will happen is after the ball, the satellite itself, gets far enough away so that it's no longer a threat to the space shuttle, the tether reel and the computers will increase its rate of getting out of sight. It will move out so that 5.5 hours from right now, it will be extended as far as it can be, which is something more than 20 meters out into space. The shuttle is flying sort of in the same orientation as an airplane would be toward the Earth, with the black bottom of the space shuttle toward the Earth. And so as this tether moves up, it's moving out further into space. The shuttle 184 miles up. The ball will be 196 miles up.
Smooth. We've turned inline 1 off. We're putting the satellite in yaw hold. There's a slight drift towards the orbiter starboard, and Andy's controlling it.
So,
copy, we see it, concur.
They are doing this to...
call with the...
Just a second, we'll listen to the NASA commentator.
Turning off one of the inline thrusters on the satellite, that's per normal operations. Satellite has 2 inline thrusters that use nitrogen gas to move it away. Both were used for the first initial separation from the boom. Only one is used for the rest of the deploy.
Tether,
also
satellite.
crew controlling the satellite's motion, ensuring that it stays very steady above the boom.
Moving a little bit to the right side of the shuttle as it flies over the Earth, and they say everything's going very well there. Once this tethered satellite gets out to its 20-meter distance from the shuttle, probably the most useful experiment that will be conducted is an experiment in the production of electricity. The copper wire that's right here in the middle of this tether cable, just because it is out there in space and it's moving through space at a speed of 17,500 miles an hour, will pick up, excuse me, an electrical charge from the Earth's magnetic field, and that will provide some electricity. We are told about 1,000 watts of electricity, enough to light at least 10 light bulbs. And in a situation, for example, where you have a space station that is in orbit for a long period of time and very dependent on a great deal of electrical power, it would be very good to have something that is not subject to much damage, say, for example, a tether like this to produce 1,000 watts of electricity. The space station will need many thousands of watts of electricity, but it's possible with a long enough tether, perhaps more electricity than 1,000 watts could be produced to provide more power for more experiments. Here's what the tether looks like. If you just do a cross-section of it, the copper is shown in this drawing, at least, is the white ring on the left side of your screen. Inside of that, there's a tiny bit of insulation. It's surrounded by more insulation. And then the yellow material, which is shown in green on your screen right now in that cutaway drawing, is actually Kevlar, the space-age material that's used in bulletproof vests and lots of other things, helmets for people in the military. It is a very strong material, this yellow Kevlar, and it's just been stranded around this copper conductor. And that, according to engineers at NASA, will allow this thing to hold that ball without breaking in space. But as you can see, compared to my fingernails or fingers here, it is not a very thick tether. The reason for that is you have to get 20 kilometers of it inside the space shuttle. So you can't have something very thick actually in there. I'm not able to tell you right now what sort of pictures we're getting from NASA, if any, but the people at the space agency say they'll try to provide us live pictures until this satellite gets about 100 feet above the space shuttle itself. If that, in fact, happens, what will happen is that the TV antenna on board the shuttle, which is how we get all of our live pictures from space, will be switched over to a different purpose. Many things at NASA have more than one purpose. The TV transmitting antenna, which is a satellite dish about this size, can also be used as a radar antenna, and the astronauts will use it as a radar antenna once they can no longer see the tethered satellite, to get a radar image of it to see how well it is doing as it floats away higher and higher into space. That concludes our live coverage of this release of the tethered satellite, Italian-made, with the most international crew NASA has ever put up into space. This is John Holloman, CNN International.
Die amerikanische Raumfähre Columbia hat vor wenigen Minuten einen italienischen Satelliten im All ausgesetzt. Wegen Computerproblemen hatte die NASA das Manöver um einen Tag verschoben. Der Satellit bleibt mit dem Shuttle über ein 20 Kilometer langes Kabel verbunden. So können die Astronauten verschiedene Experimente durchführen. Unter anderem geht es um die Stromgewinnung für die künftige Raumstation Alpha.
The latest on the Shuttle Columbia's cast of an Italian satellite. Stay with us. An hour ago, astronauts aboard the Space Shuttle Columbia began casting an Italian satellite tethered by a thin 19-kilometer-long wire. The operation is one of NASA's most dangerous. As the astronauts carefully guide the satellite, they have to ensure it doesn't bump into the shuttle. Also, reeling out the cargo may be tricky since the tether may vibrate in unexpected ways. The long tether is an experiment itself. Scientists expect the wire to generate electricity as it is dragged through space. Tethers like this one may one day power the proposed International Space Station.
Der Fesselsatellit, mit dem die Stromerzeugung im Weltall getestet werden sollte, riss sich los.
Zunächst läuft noch alles nach Plan. Langsam löst sich der Satellit von einem Turm aus der Ladeluke der Columbia. Plötzlich aber reißt das 20 Kilometer lange Verbindungsseil. Mit einer Geschwindigkeit von mehr als 160 Kilometern pro Stunde entfernt sich der umgerechnet rund 560 Millionen Mark teure italienische Satellit von der Weltraumfähre. Ratlosigkeit bei den Experten der US-Weltraumbehörde NASA in Houston. Denn bereits 1992 war ein Versuch mit diesem Satelliten wegen technischer Probleme gescheitert. Für die 7 Astronauten an Bord der Columbia besteht keine Gefahr. Der 545 Kilo schwere Satellit droht nicht mit der Raumfähre zusammenzustoßen.
The tether has broken at the boom. The tether has broken. It is going away from
Shuttle astronaut Jeff Hoffman shouts the bad news to NASA Mission Control on Earth. The tether wire which connected the satellite to the shuttle broke. The satellite has been lost. Its loss is a blow to NASA and the Italian Space Agency which built the satellite. Despite the setback, the astronauts were never in danger during the experiment, which was aimed at generating electricity in space.
Well, CNN's John Holloman's been covering the developments on board Columbia. He joins us now with the latest. Welcome, John. What can you tell us?
Riss, this all happened about 15, 16 hours ago. It was a very bad time for NASA. The astronauts at this moment are preparing to lower the boom used to launch the tethered satellite yesterday. They're preparing for a news conference 2.5 hours from now to tell reporters more about what happened. This is live picture from Columbia. That's the bottom of this boom. It will begin to collapse and just sort of drop down into the payload bay. The 12-mile-long tether broke very near to the shuttle, in fact, inside this boom. The tower is made of flexible strips which can bend and fold, sort of like the stays in a sailboat's sails. That's how they get this boom to extend and collapse so easily. A few minutes ago, NASA showed us close-up at the end of the tether, and you could see that the white outer cover of the tether itself was blackened. It looked like it might have been burned or melted for some reason. Finding the cause of this will be a major project for NASA managers.
The formal investigation team is still being formed, so I do not know who will lead that formal team yet. We are looking at a number of other teams, of course, to provide supporting information and supporting data. The data has been and is being collected and safeguarded at the 3 centers, including ground processing data at the Kennedy Space Center. And once those teams are formed and the formal investigation team is finalized, then they will begin sifting through all that data to see if they can establish any primary or contributing causes.
We'll take you back into the cargo bay of Columbia to show you this live picture. You might, in fact, while we're talking, begin to see this structure collapse down into the shuttle. Now that the satellite equipment is ready for its return to Earth, the astronauts can go back to their more normal duties, things like growing crystals, doing microgravity research. Over the weekend, the mission was extended to 15 days, but it has just been cut back to its original 2-week length now. This means the astronauts will come home on March 7th. One more thing, the astronauts will hold a news conference from the shuttle in 2.5 hours from now. For CNN International's viewers in Europe, we'll have that for you live. Again, that's 2.5 hours from right now, Riz.
John, To what extent were they expecting this kind of thing, or maybe hoping to avoid this kind of thing, though it was expected?
Well, they hoped it wouldn't happen, of course. They've done a great deal of computer modeling, 4 years of practice since the last tether satellite attempt was a failure. And they really thought they had this down. They had solved a couple of problems over the weekend with computers on board the shuttle that had threatened to cause the tether to get too tight as it was going out or something. And but they did tell us over and over again, this may not work. It's a risky business and all of that. Dan Golden, the administrator of NASA, called up to the astronauts a couple days ago and said, look, fellows, and they're all men on this mission, by the way, 2 from Italy, 1 from Switzerland, and the rest from the United States, but told them safety is a lot more important than anything else to what you're doing in space today.
Well, John, one of the things I remember hearing was that there was the fear the cable would snap and whip back and actually may cause some damage to the craft itself.
Well, when it broke, there was fear in the voice of astronaut Jeff Hoffman. He was shouting down to mission control, the tether's broken, get it on television, get a look at it quick, the tether is broken. He was very excited. And the worry was that if the tether broke 12 miles away from the shuttle, up at the satellite end, that 12-mile wire, I have a piece of it here, you can see just how thin it is, might wrap itself around the shuttle, wrap it around the cargo bay, perhaps jam some of the equipment on the outside and make it very difficult for the astronauts. If the tether were going to break, this was the ideal place for it to break, at an end closest to the shuttle. Then the 12-mile long very dangerous object is now 2,000 miles away from the shuttle and no more a danger to the astronauts.
Well, knowing this was a possibility, was there no contingency plan? Was there nothing they could have done to protect themselves?
Well, yeah, what they would have done had this, the worst of all possible things happen, this 12-mile wire begin to spin its way around the shuttle, they would have conducted a spacewalk. A couple of astronauts were prepared to do that, go outside with wire cutters, basically, just sort of like you'd use to cut an electrical cord at home, and cut this stuff and get it off of the shuttle so they could close the doors and prepare themselves for the return to Earth. So they certainly had a plan for it, but they really wanted this experiment to work out successfully for the first time.
It's a shame after so much success. What can we expect from the press conference?
Well, the astronauts are going to be asked whatever reporters want to ask them. We're not going to be able to participate just for a technical reason. The reporters at NASA centers in Florida and in Texas and in Huntsville, Alabama, where the tethered satellite was sending its data, will be able to ask questions. And they'll tell us their impressions, I imagine, of what happened. And for our viewers who are able to see that, it'll be interesting. For those who don't get to see it live, I'll come back later and share with everybody what the highlights of that news conference were.
John, thanks very much. And here's John Holloman updating us on the situation with the space shuttle.
Bei einem Experiment zur Stromerzeugung riss das nur zahnstochendünne Seil zwischen der Raumfähre Columbia und dem Forschungssatelliten. Glücklicherweise konnte der Kommandant der Raumfähre Seil und Satellit rechtzeitig ausweichen. Die Columbia bewegte sich zum Zeitpunkt des Unfalls mit 28.000 Stundenkilometern um die Erde. Ganz vergeblich war das Experiment trotzdem nicht. Die Astronauten konnten Daten sammeln und eine Stromspannung von mehr als 3000 Volt messen.
Das Space Shuttle Columbia hat im Weltraum einen 660 Millionen Mark teuren Satelliten verloren. Der italienische Forschungssatellit sollte an einem 20 Kilometer langen Kabel durch die Magnetfelder der Erde gezogen werden und dabei Strom produzieren. Das Kabel war bereits 19 Kilometer lang abgewickelt, als es riss.
Sollte der Satellit die Erdatmosphäre erreichen, so verglüht er. Wäre das Experiment geglückt, so hätte der Satellit im Schlepptau der Columbia bis zu 5000 Volt an Strom erzeugt. Jetzt aber, so die NASA-Sprecher, seien die Chancen, den Flugkörper wieder einzufangen und damit das Projekt zu retten, äußerst gering. Der Verlust ärgert doppelt. 1992 nämlich hatte sich ein baugleicher Satellit in der Leine verfangen. Auch damals mussten die Forschungsarbeiten ergebnislos abgebrochen werden. Dies sind die letzten Bilder des Satelliten, kurz bevor er endgültig im All verschwand. Von den Ergebnissen dieser Versuche versprechen sich die Raumfahrtexperten nicht nur Rückschlüsse über die Erdatmosphäre, vielmehr war der Satellit als Vorbild gedacht, die geplante internationale Weltraumstation mit Energie zu versorgen. Trotz des neuerlichen Rückschlags will die NASA an diesem Experiment festhalten.
Kostspieliger Rückschlag für die Weltraumforschung. Die US-Raumfähre Columbia hat einen mehr als 600 Millionen Mark teuren Satelliten verloren. Der Satellit TSS hing an einem dünnen Draht im Schlepptau des Shuttle und entschwand plötzlich mitten in einem Experiment in die Weite des Alls.
Das ist das Letzte, was von TSS zu sehen war. Ein verdrilltes Stück Draht. Der millionenteure Satellit schleppt es hinter sich her, als er auf Nimmerwiedersehen verschwindet. Das Kabel aus Kupfer, Nylon und Teflon ist nur 2,5 mm dünn. Der Satellit wiegt eine halbe Tonne. Das konnte nicht gut gehen, möchte der Laie sagen. Dabei hatte alles ganz planmäßig angefangen. Das Schleppseil war in der Nacht reibungslos auf 19 Kilometer Länge ausgefahren worden. 2 Tage lang sollte TSS vom Space Shuttle durch das Magnetfeld der Erde gezogen werden und dabei Strom erzeugen. Plötzlich kracht es und der Satellit macht sich bei rund 28.000 Stundenkilometern selbstständig. Zu diesem Zeitpunkt sollen 3.000 Volt durch das Kabel geflossen sein. Eine elektrische Entladung könnte den Bruch ausgelöst haben. Ein Trost bleibt, diesmal war es wenigstens nicht so gefährlich wie 1992, als das gleiche Experiment schon einmal scheiterte. Damals war der Satellit dicht beim Shuttle außer Kontrolle geraten und wie eine Abrissbirne auf die Atlantis zugeschleudert. TSS ist vermutlich für immer verloren. Er saust auf einer elliptischen Bahn unkontrolliert um die Erde und wird möglicherweise verglühen.
Die US-Raumfähre Columbia hat einen 640 Millionen Mark teuren Forschungssatelliten verloren. Aus noch ungeklärter Ursache riss das Verbindungskabel zur Raumfähre. Danach trudelte der Satellit ins All und verschwand. Er sollte von der Columbia durchs Magnetfeld der Erde geschleppt werden und dabei Energie erzeugen. Sozusagen als Riesendynamo, der in der Zukunft zum Beispiel Weltraumstationen mit Strom versorgen könnte.
Die Astronauten waren noch bis zum Sonntag froher Dinge. Es funktionierte alles hervorragend. Und hier sehen Sie, wie der Faden gerissen ist. Das aufspiralte Kabel ist ein Zeichen dafür, dass es gerissen ist. Und der Satellit saust hinaus ins Weltall und ist unwiederbringlich verloren. Ja, das ist heute Morgen passiert um 2:30.
Our satellite breaks loose from the Space Shuttle Columbia. What happens now? We'll grab hold of CNN's John Holloman and explain.
Moving north above the Great Barrier Reef.
A live picture there of a piece of equipment extending from the Shuttle Columbia. Officials down on Earth at the U.S. Space Agency NASA are scratching their heads and expressing some disappointment over the failure of a multi-million-dollar experiment Sunday on board the shuttle. The disappointment, though, is mingled with some relief that the failure did not create a more dangerous situation. CNN's John Holloman has been covering the shuttle mission. He joins us now to explain what went wrong.
Well, a piece of wire, a piece of tether that looks just like this, Jonathan, broke apart in space. It was frayed at the ends. We just had let me show you, in fact, a picture of the end of the tether as it looked at the end of the broken end right there. You can see the copper conductor a little bit, a couple of strands of the yellow Kevlar insulation, and then the main body of the tether itself. I don't know if we have a live picture coming down. Maybe this is a live picture coming down right now from the Shuttle Columbia. At any rate, what's going on right now is that the boom on Columbia, you see it sticking up there out of the cargo bay, is just at this moment beginning to collapse down in there. It's going to be lowered into the cargo bay without its precious satellite cargo aboard, and that's the big disappointment. The boom being lowered because the crew is trying to get back on schedule for science experiments after last night's failed effort to launch the tethered satellite. They got it out, but it cut loose and is lost in space. The astronauts are coming home a day early, March 7th, rather than 8th, because they don't have to spend tomorrow reeling in the lost satellite. Pictures from the cargo bay cameras show what appears to be a burn on the tether at the point where it broke. NASA has been planning this mission since 1992. Back then, the satellite was only able to get about 240 meters from the shuttle when they wanted it to go out 20 kilometers. NASA managers putting the best face they can on this failure, saying that the data collected as the tether was reeled out 19 kilometers above the shuttle will be helpful to scientists on the ground. But the fact is the tether wasn't supposed to break, and the satellite was supposed to come home. With the shuttle, it won't. And 19 kilometers of the thin cable are loose, orbiting more than 3,200 kilometers behind the shuttle. Eventually, the satellite will burn up in the Earth's atmosphere. By the way, Jonathan, a few minutes ago, I spoke with John Pike. He's a sometimes NASA critic. He is a spokesman for the Federation of American Scientists about the loss of the experiment. I asked him to quantify this loss for NASA and the Italian Space Agency, which built the satellite.
The tether was going to break. This was probably about the best place for it to break, because remember, what you're talking about here is basically the equivalent of a big wrecking ball on a cable that's about 12 miles long. If it had snapped at the other end, you would have had that cable come slithering back towards the shuttle, and I would hate to see what would happen in a situation like that.
Is this the kind of incident that's going to cause NASA's critics, and there are many of them out there, particularly in Washington where you are today, who are going to pile on?
I don't think so. This was really a pioneering experiment. This is something that just hasn't been done before. They've had difficulties with it in the past. It's not on a critical path to some important future mission, and I think that if they didn't have setbacks like this occasionally, it would simply be because they weren't trying hard enough. So I don't think that it's going to have much political fallout.
Jonathan, the astronaut's going to talk to reporters in an hour and 15 minutes from right now. Some of our viewers on CNN International will get to watch that, those in Europe, I'm told, and they'll be able to tell us more about their experiences when this happened, I guess.
I want to ask you right now, though, more about this cable, because if you're watching this, this is about the size of a clothesline. I've eaten pasta that was thicker than that.
Yeah.
Why didn't they use something stronger?
Well, this is about as strong as you can get in something this size. It had to be this thin in order to get 20 kilometers of it stored inside the space shuttle. You imagine a 20-kilometer reel of anything, including pasta, and it's going to fill up the room. It's just too much volume. So they needed something very, very small in diameter that was strong. I talked to the manufacturer of this product yesterday, and he says what you've got inside here is the copper conductor with some Kevlar insulation around it. You've got this stuff, which is the strengthening agent, same stuff they use in bulletproof vests and military helmets for NATO troops, Kevlar, and it also can be stranded because it is so strong to use in this. And it just appears from the pictures that something caused a burn on the side of this cable as it was reeling out through that tower we saw on TV Live a couple of minutes ago. And that was far from a final explanation of this, but it certainly looks like burn marks right at the end of this where the break occurred. Could have happened because of all the electricity that it was generating down its length. It could have happened for a number of reasons, but it'll be a while and we'll find out, I think.
The cord's gone, the satellite's gone.
That's right.
John Hallman, thanks for being here with us.
Okay, John.
What happened?
Well, the shuttle's main experiment, the main job the astronauts had to perform on this 2-week mission was to reel out a satellite. You can see that satellite at the end of about 12 miles of tether wire right there in the center of your screen. What happened at about 8:30 Eastern Time last night was the tether broke. You can see it begin to ripple as it broke loose from the space shuttle, and it started looking like curly-Q French fries, really, as it just sort of wrapped up around itself on the end. There's what it looked like just a few seconds after the tether broke. This was a bad thing. The satellite is worth millions of dollars. The tether itself is worth millions of dollars. And we'll show you the end of the tether where it broke. Part of it was right there connected to the space shuttle, so the astronauts could take this close-up view out the back window of the command part of the shuttle. And if you look at it in different lighting situations, and the astronauts and we and scientists on the ground have been doing that all day today, you can see that at the very end of the tether there is a burn, or what looks like a burn. It looks like what that tether wire would look like if you took a match and lit it at the end of it. What would cause it to burn out there in this tower? One of the things we know about the tether, this is an actual piece of it that we got from the manufacturer. The tether's outer skin is a white mylar material. Inside that is this yellow stuff, which is Kevlar. I keep describing this as the stuff that some football helmets now, certainly military helmets and bulletproof vests are made of. It's very strong, very tough material. And then inside that is a copper wire. One of the main things that, and this sort of looks like the picture you just saw on TV, except that there, in that picture, you might have been able to see a burn right here. Now, we're looking into the crew cabin. I see Shuttle Commander Andy Allen and his crew. Andy Allen will begin this news conference, I think, in the next 15 seconds or so.
Doing a voice check right now.
Okay, that's good.
So what is it that we need to know? What don't we know?
Well, we don't know what they saw with their eyes when this thing happened last night. We heard Jeff Hoffman sort of screaming into the microphone. He'll talk about that, I'll bet. Okay, I think they're about ready to go. Let's listen.
Looks like it.
Oh, let me describe how it was as far as the tether break from up here and where we were and what we were doing. And then we'll probably go into the questions from there. We had put the red shift to bed. The red shift is Mauricio and Scott and Umberto. And the other four of us were up here on the flight deck, just like we had simulated. Jeff was looking out the aft window, overhead window. We had a camera set up in the other overhead window. Franklin was working the spec displays up in the PLT's chair. Claude was in the aft here working on some of the cameras, and I was in between the forward and the aft looking at some of the monitor displays as well as some of the profile timelines as well as looking out the window. When we had the tether break, Jeff was the first one to notice it. He called the tether break. I moved to the aft station like we have practiced and simulated and started assessing what the tether looks like outside and whether any tether is coming back towards the orbiter. There's always been our utmost priority to make sure that we could keep safety, and we had never had any doubts in our minds that we could keep ourselves safe. But we had to have a visual of what was going on. As it turned out, it was very benign as far as where the tether broke. Having the tether break inside the boom was probably the best case that we could ask for as far as any types of maneuvering or evasive maneuvers that the orbiter had to do. None of those were necessary, and we assessed that pretty rapidly. And from then on, we just took some videos of the tether and the tethered satellite as it was going away from us. It got quite a boost away from us, so it was opening up at a pretty high rate. And I think that pretty well describes where the four of us were at the time of the tether break. And with that, rather than talk any more about anything else we think right now, we'll just go ahead and go on with the questions, and we'll pick things up from there.
Okay, we'll start here at JSC. Please give your name and affiliation.
This is Mark Crow, the Houston Chronicle for Jeff Hoffman. You observed the break, and you also observed some burning or charring on the end of the tether in the shuttle. Do you believe there was any relationship between those two observations? And if you do, what do you think it was?
We are trained observers up here, and what I was trying to do was report what I see. The reference to discoloration was exactly what we saw out the window. I heard my crewmates confirm what I was seeing through binoculars and telescopes before I reported it. And the comments were intended to describe the visual appearance and the colors rather than any cause. I think it's very important, accident or incident like this, to not jump to any premature conclusions, and we'll wait and see what happens. We obviously now have the tether back inside. We will be bringing it back to the ground, and everybody, yourself included, will get some good pictures and a good chance to assess what really happened.
This is Stephen Young with Astronomy Now. Question for Jeff. Although obviously it wasn't the sight you wanted to see, the tether as it sprung away from you was a very dramatic sight. I wonder if you could actually describe it and some of the dynamics you saw there.
Well, first of all, I think we were all really looking forward to knowing what a tether, that 20-kilometer-long tether in space would look like, and we have seen that. I guess one thing that surprised me, I expected sort of to see the tether disappear up into nothingness. And in fact, as long as the sun was out, the satellite was always clearly visible as a glowing star on the end of the tether. Quite beautiful. The tether was slowly curved. This curving of the tether, I think, fascinated us all, and we were trying to take pictures of it, and that's in fact what I was doing with a telephoto lens when I noticed that instead of being nice and straight, I saw a little rippling along the tether. It sort of reminded me of the incidence of low tensions that we had at the very beginning of the deploy, and these ripples grew into waves. I realized then that we had a slack tether, and of course at that point it indicates to us that either the tether has jammed or the tether has broken. So we basically threw the cameras out the windows. I looked back at the boom, and as Andy said, once we realized that the tether had broken at the very bottom, then we understood that it posed no danger. And at that point, we tried to photograph it, and we did see this big, huge jumble of tether moving away from us with no end on it. And that's basically, after a few minutes, it disappeared into the sunset, and that's the last we saw of it.
Stephen Govain, KTRK-TV in Houston. Can someone tell me if there was any kind of data being taken in through the tether or from the satellite? Was there any charge in the tether at the time?
There was a lot of data being taken in. A lot of that data is on the ground, and perhaps the ground controllers are much better able to answer that question directly. We have a reduced set of data available to us, and we were monitoring that data all the time.
Over here.
Okay, Felicia Griffin, KNWS in Houston. I wanted to know who, if anyone, had the responsibility for spooling the tether in the first place before the mission, and what procedures were taken to inspect the integrity of the tether before the mission began.
Well, I think the best way to answer that one is as far as the Tether Project. The Tether Project office is in Marshall Space Flight Center, and the mission manager for that, who probably you have already talked to, is a man by the name of Robert McBrayer. We basically had to concentrate our efforts on training and executing all the plans that come before us and working all of the science. The ground certainly has more data than we have. And actually, at this point, they have certainly more than we have, because we've given them everything that we have on board as best as we can. So that one's kind of a difficult one to answer, and it might be more appropriate for probably the project office down there at Marshall to answer that one.
Okay.
Philippe Messeyer, Le Matin. A question for Claude Nicolier. Can you tell me your feelings after the rupture, and if you thought you could make an EVA at a point?
Well, of course, it's a feeling of disappointment for us here on board, as well as for many people on the ground. That's the first feeling that I can express. Now, whether there was a possibility for an EVA or not, I guess there was a slight chance of a snag of the tether somewhere in the so-called lower tether control mechanism between the reel and the point where the tether exits the cargo bay. There was obviously a lot of slack tether there, and there was a possibility of a snag there. So possibly we would not have been able to reel in the tether as we did this morning. So there was a possibility of an EVA, but it did not happen.
This is Mark Carreau, the Houston Chronicle again for Franklin Chang Diaz. I just wonder if you had how much you knew or could tell about the current flowing through the tether, its stop, and the voltage potential, which I guess was higher than the models expected. And if you did see that, did it raise any concern?
No concerns. The actual behavior of the system was quite as expected, maybe a little higher than expected, but it was very gradual, a gradual build-up of the current and voltage capability as the tether got longer and longer. We were monitoring the science instruments, and we were monitoring the current and voltage as we went through the various functional objectives. Everything seemed to be perfectly nominal, and I was basically back and forth scanning the forward displays where the spooling was taking place, and the electron guns firing on the back displays. Everything was completely nominal.
Stephen Govain, KTRK TV. I'd like to get a comment from either of the two Italian crew members on what this means to them.
Well, of course, it's a big loss for the science. We were almost there. I mean, the scientific experiment have been working successfully so far until the time that the tether break. And of course, in Italy, there is disappointment for this, the loss of the satellite. And it caught us by surprise, because we were almost there. What I could add is that from a personal point of view, of course, I'm disappointed, because we came here to do a job, and we were well trained for that, and we could only partially complete it. I guess these are the risks that you have to take when you try to explore new ways in science. And I just hope that this does not mean a stop, especially in Italy, for TSS applications, and that people will try again.
Columbia, that's all the questions here in Houston. Please stand by for the Marshall Space Flight Center Public Affairs Office.
Columbia, this is Marshall PAO. How do you hear me?
Yeah, loud and clear, Marshall.
All right, John, while we're waiting for Marshall, I guess we're waiting for a news conference from Ricardo Alarcon, who's the Cuban National Assembly president, any moment now. But what have we learned right there?
Well, we've not learned a lot. Well, we've learned what everybody was doing at the time that the tether broke. We've learned that everybody's real sad that it happened. We've learned that they were surprised, and we've learned that it was beautiful when it kind of wound up and went away. This news conference will continue. The astronauts only have about 30 minutes of satellite time, and so they've got about 10 or 15 minutes left.
The very first question was about the discoloration, the burn at the end. We didn't learn much about that, but were they trying to establish whether there was a surge in current through there?
Yeah, because what this tether does is, or what it was supposed to do, the longer it got, the more electricity was supposed to be pulsing through it into some electron guns, which would shoot the current off into space. There's the picture that the astronauts took a little bit earlier today of the actual end of the tether in the space shuttle where the break was. And if you can see, just up from where it becomes frayed, there's some things that do look a little bit discolored. In lower light, they look black. They look like what would happen if you lit a match to the end of this. It just looks melted. Could the current have melted it? Could there have been some sort of static electricity spark out there in the tower that caused it? We don't know.
Still a lot to be pinned down.
Yep.
This graphic shows what should have happened. The satellite, a white ball 5 feet in diameter, rises from Columbia's cargo bay on top of a 40-foot tower. With the tower fully extended, the satellite sets off into space until the tether is fully unwound. It's then dragged along, creating electricity from the magnetic field surrounding the Earth's surface. It nearly worked. The tower rose perfectly, half a ton of satellite set off, and was very nearly fully extended when the tether snapped. The only good news for NASA is that it had started generating nearly 3,000 volts of electricity. The crew say they have no idea what caused the tether to snap. NASA's disappointment was also clear.
Yes, sir. Well, those are some tether dynamics we did not want to see.
NASA say the satellite will eventually fall and will disintegrate when it hits the Earth's atmosphere. Robin White, ITN.
A thin tether is torn and a satellite is lost in space. The U.S. space agency NASA has been holding a news conference to talk about the failure of a multi-million-dollar experiment Sunday. CNN correspondent John Holloman has been watching all of this, and he'll explain why it happened. Amazing story.
Well, they still don't know for sure why it happened, Jonathan, but they're trying to talk about it at least. The astronauts have had a news conference live from space. Lee Briscoe, one of the program managers, just completed a news conference on the ground in Houston in the United States. So the astronauts 180 miles above the Earth, and the other Lee Briscoe news conference from Houston. First, we'll go to space, and then we'll go to Houston. The astronauts and the ground managers really disappointed that they lost the tethered satellite. Astronaut Jeff Hoffman was on the 1992 mission, which also failed to get the tether out and bring it in. And one more thing, before we listen to Hoffman, I'll tell you that Lee Briscoe says it may be possible for NASA managers to turn on that satellite that's now not totally lost in space. So listen to both of them.
Scientists have lost a lot, and I deeply feel for them. And we were really looking forward to demonstrating that we could actually retrieve a satellite from 20 kilometers, which of course is something that has never been done, and we've put an incredible amount of work into that.
And one of the thoughts and things that we're looking at is, can we go back and command to the satellite next time it comes over and command some experiments back on and take data from it? So we haven't given up on still trying to get some good scientific data and more data out of the satellite.
But you can probably see long faces all over the place, in space and down on the ground, and also in Italy. The Italian Space Agency, of course, spent millions and millions of dollars on this satellite, which they may be able to get a little bit more data out of it, as Briscoe said, but they're not going to ever see that satellite again on Earth.
This is an amazing story. We should back up just a little bit and let people know the reason this satellite is gone is because a long piece of string broke.
Precisely right. The tether was 20 kilometers reeled out of this huge cable reel in the cargo bay of the shuttle. When it broke back at the tower that connected the shuttle to the satellite as before it left the shuttle. And It wasn't very dangerous to the astronauts, but it was certainly costly. What is now floating through space in an orbit about 130 by 120 kilometers, just kind of going around the Earth, is this 1,100-pound satellite with this spaghetti-looking tether kind of coming and going up against the satellite. It's very hard for them to track and try to figure out what it's going to do, but they predict now at NASA that this will re-enter the Earth's atmosphere in 25 or 30 days and be burned up.
Okay, CNN's John Holman watching this for us. Thanks very much.
Of the Earth from the shuttle. On board, they're conducting a series of science studies before returning to Earth late next week. But the crew remains disappointed over the loss of an experimental satellite. The thin tether connecting the satellite to the shuttle broke on Sunday, allowing it to float away. Well, our viewers in Europe and Asia can see an interview with the Shuttle Columbia astronauts here on CNN International in about 4 hours from now.
Reaches the maximum northerly point of an orbit.
Astronauts aboard the Space Shuttle Columbia are staying busy despite a mission setback. They're conducting a series of studies before returning to Earth next week, and they are still trying to figure out what went wrong Sunday when a thin tether holding a satellite snapped, sending it on an endless voyage into space. In our focus, CNN's John Holman talked with the shuttle astronauts about the mission, including some scary moments during takeoff.
As we watch the engines come up to full speed, they start about 6 seconds or so prior to the liftoff. Scott called out that the left engine only went up to about 45%. So the first thought that came through my mind is that would be a pad abort. The series of checks that the engines have to go through means the engines need to be above 90% for us to get liftoff. So if that gauge was correct, we were expecting a pad abort there where the engines would have shut themselves down automatically, and we would have not gone anywhere for quite a while. As it turned out, I was a little bit surprised the boosters lit, so we were definitely on our way. And shortly after that, we had what we call a command path light, meaning that the engine may or may not be throttling, or the indications are on our computers on board that the engines may not be throttling correctly. As it turned out, they were both false indications and cleared themselves up. The command light cleared itself up shortly thereafter, and the gauge that we were looking at for the engine was just biased to the low side for us. So we had a couple moments there that we got a little bit of an adrenaline rush, but ground quickly and very adeptly cleared it up for us with our call.
I asked a group of 6th graders from Wright Denny Elementary School in West Virginia to come up with some questions for you today, and many of these students want to know if you were ever scared during the mission. Let me direct that one to Jeff Hoffman and to Scott Horowitz. Jeff, you seemed pretty agitated when you reported the broken tether to Mission Control last Saturday.
It was a huge surprise. I mean, I think what you heard in my voice was definitely an urgency that we may well have to do something. And of course, we've always known that if the tether breaks, and it breaks at a long distance away from the shuttle, you know, the tether is stretched a little bit when it's in space, so it's like a huge rubber band that you've pulled out. And if it breaks away from the shuttle, then we've got that huge coiled rubber band coming down at us, and we've got to do something about it. That's why Andy Allen, as soon as I called tether break, rushed over to the window, threw the camera out of the way. I threw my camera away, and you know, we were ready to look at the tether coming back at us, and Andy was going to fly the orbiter to stay clear of it. You hardly have time to get scared in a situation like that because you really have to act, and if you're really scared, then you can't do anything. But we were certainly surprised. Very quickly, though, we realized that the tether had broken right at the shuttle, so instead of coming back towards us, it was moving away from us, and we and the shuttle were in no danger. And at that point, it was, of course, it was a big shock, and our responsibility then is to collect data and to try to photograph what's going on so that we can figure out after the mission what happened.
Exactly.
As far as getting scared during the launch, I'm going to give that over to Scott because this was his first flight, and as the pilot, he was responsible for the engines.
Okay. Scott, we didn't hear from you until a few minutes after the shuttle was in orbit, but it sounded like it might have been a heart-stopping moment there, at least for a second or two.
Well, actually, the first indication when I saw the engine not spool up, I actually wasn't scared at all because I said, oh, this is just like the sim. There's going to be a pad aboard, no problem. You can imagine my surprise when the main SRPs lit and off we went off the pad. I was more in a state of shock than anything else. And then when I saw the command light, I was like, boy, this looks like a bad simulation run. And then we have a backup indication on one of our computer screens. So I looked at that and saw those numbers were good. We got the call from the ground right away, confirming that the engine actually was good. And I know they have a lot more insight than us because of their telemetry. And then I was able to relax a little bit more and enjoy the ride.
How great is the loss of this particular tethered satellite and the tether itself for the Italian Space Agency, which was responsible for it, the place you work, and to you personally, because this has been certainly something you've been working on for years and years of your life?
For me, it's a big loss because I have been working on this project for almost 10 years. For the space agency, I hope for the Italian Space Agency, I hope that this won't stop the study and the effort in making tether study and further tether mission, because I really believe that the tether has a future, has so many applications in space that it's really worthy to continue the program. The loss of the satellite itself is a loss, but we knew that we couldn't fly this satellite any longer because it was, too old at this point. So it was designed for two missions, and these two missions were accomplished.
The Space Shuttle Columbia mission, our focus this hour.
Thomas Reiter ist heute von seinem Weltraumflug zur Erde zurückgekehrt. Er landete mit 2 russischen Kosmonauten bei Arkalik in der Steppe von Kasachstan. 180 Tage war Reiter in der Raumstation Mir. Er war damit länger im All als jeder westliche Astronaut vor ihm. Aus Arkalik, Ina Ruck.
Diesig war es heute Mittag in der kasachischen Steppe. Ein wenig länger als gewöhnlich hatten die Bergungshubschrauber nach der Raumkapsel suchen müssen. Die war mit genau 4 Minuten Verspätung auf dem verschneiten Steppenboden aufgeschlagen. Ein halbes Jahr waren die 3 Kosmonauten in der russischen Weltraumstation Mir gewesen. Den Heimweg, immerhin 400 Kilometer, haben sie in nur wenig mehr als 3 Stunden zurückgelegt. Thomas Reiter wird als Zweiter aus der Kapsel gezogen. Man sieht ihm die Strapazen an. 180 Tage im All, länger als Reiter haben das bisher nur Russen geschafft. Als erster Nicht-Russe war er verantwortlicher Ingenieur an Bord und als erster Ausländer hatte er auch Experimente außerhalb des Raumschiffs durchführen dürfen. Vor allem Russisch hat er geredet im letzten halben Jahr. Auf die Frage, ob er überhaupt noch Deutsch könne, sagt er ja, auf Russisch.
Da. Sie sehen, hin und wieder spricht man natürlich Deutsch. Klar, über Funk mit der Familie. Ab und zu, sehr selten, allerdings auch mal mit der Kontrollstelle. Aber die meiste Zeit Russisch und Englisch.
Schon 2 Stunden später der feierliche Empfang auf der Erde. Mit kasachischer Folklore, denn die Kosmonauten sind in Kasachstan gelandet, ein paar 100 Kilometer von der russischen Grenze entfernt. Volksmusik und Trachtenhüte für die beiden russischen Raumfahrer Avdejew und Gitsenko. Thomas Reiter wird das Kasachenkostüm erst später anprobieren können. Ihm haben die Ärzte vorerst strenge Ruhe verordnet.
Amateur astronomers may get a treat next week, a naked-eye view of a wandering satellite. It's a satellite that NASA had hoped to fly tethered to the Space Shuttle Columbia on the current mission. The satellite was released from the orbiter last weekend as planned, but just hours later, the tether snapped. Late in the week, ground controllers decided Columbia did not have enough fuel to rendezvous with that satellite and possibly bring it back to Earth. The satellite and its leash are gradually falling toward Earth, and NASA predicts they'll be visible from some places in North America starting on Monday, and even sooner in other parts of the world. NASA has a website with all the details. You can find out that address on our homepage. That's at cnn.com. The satellite is expected to sink into Earth's atmosphere and burn up sometime in the next 2 to 4 weeks.
Erdumdrehung entfernt davon landet sie, im Norden Ghanas, in der Nähe des kleinen Dorfes Batorigo.
Die Nachricht spricht sich wie ein Lauffeuer herum, auch in Tamale im Januar 95. Ein seltsames Objekt sei an einem abgelegenen Ort gelandet. Der Journalist Abdallah Qasim hört davon, will mehr erfahren.
Aber wir konnten den Ort nicht erreichen. Näher als auf 35 Kilometer kamen wir nicht heran. Die Gegend ist von Flüssen durchzogen. Selbst wenn wir ein Boot genommen hätten, wären es immer noch 35 Kilometer Fußmarsch gewesen.
Auch ein Jahr später ist es eine beschwerliche Fahrt. Die deutschen Raumfahrtexperten wollen die Absturzstelle sehen. Nach 7-stündigem Umweg von Tamale aus erreichen wir das abgelegene Dorf. Die Bewohner sind neugierig und überrascht, nach dem unbekannten Flugobjekt, das vom Himmel fiel, schon wieder ungebetenen Besuch zu bekommen. Ein lauter Knall habe damals die Stille des Nachmittags zerrissen, erzählt Isaidi, der Bruder des Häuptlings. Der Überschallknall war meilenweit zu hören. Er hat die Menschen geängstigt. Sie flüchteten in ihre Häuser. Erst nach Tagen entdeckten Dorfbewohner die Kapsel. Sie wollen uns zu dem Absturzort führen. Nach gut 4 Kilometern Fußmarsch durch die Steppe machen sie plötzlich Halt. Ganz langsam sei die Kapsel zu Boden gesegelt, erzählt Salifu Isahaku. Fast eine halbe Stunde habe es gedauert, bis Express auf den Savannenboden aufsetzte. Herr Lippert, an dieser Stelle soll Express tatsächlich gelandet sein. Sind das hier noch Überreste?
Das sind ganz eindeutig Überreste vom russischen Hitzeschildmaterial, Glasfaser aus Russland. Das ist tatsächlich die Stelle, in der Express gelandet ist. Heute ist genau 400 Tage, nachdem wir im GESOC enttäuscht die Monitore abgeschaltet haben. Und ungefähr zu dieser Uhrzeit, das ist unter 18 Uhr lokale Zeit, ist Express hier gelandet. Ich muss schon sagen, ich bin doch ziemlich beeindruckt, was man von einem Computermonitor in Deutschland aus anrichten kann.
Verletzt haben die deutschen Wissenschaftler mit ihrem Prestige-Experiment niemand, nur das Gras in der Umgebung brannte durch die aufgehitzte Kapsel. Für die missglückte Landung haben die Dorfbewohner ihre eigene Erklärung. Wenn eine Frau nicht den ausgewählten Mann heiraten will, so hat Gott den neuen Ehemann geschickt, sagt ein Sprichwort bei ihnen. Genauso sei es mit der Kapsel. Express sei in Ghana und nicht in Australien gelandet, weil die Götter wollten, dass sich Ghanaer und Deutsche kennenlernen. Aufwendig bergen die Ghanaer die Kapsel und bringen sie hierher auf den Militärflughafen in Tamale. Die wissenschaftliche Erklärung für den Absturz ist ganz nüchtern und trocken.
Der Unterschied zwischen Südamerika und Pazifik ist, zwischen Pazifik und Ghana, hört sich groß an. Für die Kapsel sind es ungefähr 20 Minuten Flugzeit, die Kapsel länger im All verbracht hat, als wir berechnen konnten.
Und wieder hilft das reine Glück der deutschen Raumfahrt. Im Februar 95 berichten ghanaische Zeitungen noch ein bisschen ungenau über eine vermeintliche russische Waffe, die vom Himmel fällt. Ein britischer Journalist liest zufällig Monate später die Berichte, kennt sich aus, schreibt selbst einen Artikel für ein australisches Fachblatt und den lesen die deutschen Wissenschaftler im Herbst 95 in Bonn. Natürlich rein zufällig. Der Rest ist wieder deutsche Präzisions- und Wertarbeit. Insgesamt 8 Leute schickt die DASA, die im Auftrag der deutschen Raumfahrtagentur die Kapsel konstruiert hat, zur Bergung. Im Inneren der Kapsel stecken noch die wertvollen Experimente. Wie ein rohes Ei wird Express behandelt und sorgfältig verpackt. Für die Wissenschaft ist es zumindest ein halber Erfolg. Teile der Versuche funktionierten. Wie genau, soll jetzt in Bremen ausgewertet werden. Mit einer offiziellen Feierstunde verabschieden die Ghanaer das unerwünschte Flugobjekt. Ihre Regierung hat sich sehr kooperativ gezeigt, keinerlei Wiedergutmachungsansprüche gestellt. Der Militärkommandant des Flughafens wünscht noch eine gute Reise.
Go, go, Express, go. Thank you very much.
Eine Transall der Bundeswehr ist extra gekommen, um das wertvolle, verloren geglaubte Objekt in die Heimat zu bringen. Dieser Flug kann als sicher gelten, aber auch in der Zukunft ist eine Überraschungslandung in der hochtechnisierten Raumfahrt durchaus möglich.
Dieses Risiko kann man grundsätzlich nicht ausschließen. Sie sehen, in der Vergangenheit ist es von russischer Seite oder chinesischer Seite oft passiert, dass ein Satellit außer Kontrolle gerät. Und wenn dieser dann, wie Express, mit einem Hitzeschutz versehen ist, so wird er auch heil, sagen wir es mal, nicht verglühen und zur Erde zurückkehren. Und dann, wo er zurückkehrt, ist letztlich der reine Zufall.
That way, southern Ontario into southern Quebec, more snow showers. Spreading on into western Ontario, some more snow is a good possibility. All the way down into Florida, more heavy rain, a good possibility there too. And in the north and western United States, more rain showers on the shoreline up into British Columbia, snow.
Add one more to the growing list of problems aboard the Space Shuttle Columbia. Just one day before its scheduled landing, astronauts aboard found a broken computer circuit on the path that controls the landing system. The craft is still scheduled for a Friday morning landing. There is a backup computer circuit, so there is no immediate danger to the crew. NASA is preparing a backup landing site at Edwards Air Force Base in California in case of bad weather in Florida, the shuttle's usual touchdown location. Earlier in the mission, the experimental tethered satellite broke away from the shuttle and has been drifting around Earth. It was seen briefly from Miami as it passed over Coconut Creek.
The U.S. Space Shuttle Columbia is scheduled to return to Earth on Friday with a new problem that may complicate that operation. CNN's John Holliman reports on Columbia's problem-plagued mission.
11, 10. The Columbia mission has been troubled ever since launch day, February 22nd.
5, 4, 3, 2, 1. And we have liftoff of the Space Shuttle Columbia continuing.
Cockpit instruments indicated a main engine problem during takeoff.
The crew reporting a errant gauge on board.
It was later determined there was no faulty engine. O-rings and the solid rocket boosters were singed during launch as well. The main mission of Columbia, to launch and retrieve an Italian-built tethered satellite, failed when the tether, the thickness of a shoelace, broke and the satellite was lost. And now a computer failure aboard the shuttle and bad weather in Florida forced NASA to prepare for a touchdown in California on Friday.
We keep our options open by not only scrambling the A-team out there, but continuing to observe the weather on both coasts.
The latest problem wasn't noticed until Commander Andy Allen was testing flight control equipment in preparation for landing. He discovered a computer system that steers the shuttle had failed. As the shuttle flew over a cloudy Florida, the crew discussed landing options.
Okay, we will bring up Edwards for tomorrow.
This is what a normal shuttle landing looks like. It must make several turns to slow its speed and to line up with the runway. If all flight control system computers failed, a landing would be almost impossible. But NASA insists that won't happen, and the crew is in no danger. They say there are 3 backup computers which will handle the landing load. What all this means is that Columbia's landing time and location are still in doubt. If Florida weather improves, NASA wants to land the shuttle there. This saves an expensive cross-country ferry operation from California and gets the shuttle back in orbit on its next mission, perhaps a week sooner. John Holliman, CNN, Washington.
NASA officials have said a passing cold front could force the astronauts to wait until the weather clears. Thursday's failure of a computer circuit was the latest problem to crop up during Columbia's troubled mission.
Mess across the eastern United States. There goes the front pushing on down into Florida, farther east, northward rather. You can see it moving on out into the Atlantic, but still up into the north and east there is snow. Boston Logan closed down for snow removal. We'll let you know when they'll get operations back in order. But still there is more snow, and more is expected throughout the afternoon across most of the north and east, falling now. Somewhat heavy in spots, but a little bit lighter in other spots. At any rate, it's going to slow you down some. Farther south now, still some snow back across Dixie, too, and down into Florida, some rain showers. And just about everywhere here, it's cold. Well to the west, we still have the very cold air, not as much wind. But the wind chills and the cold air, the combination will make you feel like winter across most of the United States throughout the day. On up into Canada, too, the snow showers extend into Ontario and Quebec and into the Maritimes. We're seeing the heavier amounts through parts of New England. Farther south and west, down through the Appalachians, it'll taper off some. Showers in Florida, some showers in the west, snow primarily, but some rain up in the north and western United States. There's the low, tracking on up the coast, still throwing moisture back into cold air, so right on into this evening, some snow showers continue. That's a look at your weather forecast. We must take a break, but
the 7-member Columbia crew is now expected to return to Earth in about 4.5 hours. NASA's still hoping for a Florida landing, but the shuttle could be diverted to Edwards Air Force Base in California.
The alternate site in California was also bypassed, and the landing has been rescheduled for Saturday morning in Florida. Yet another computer problem caused enough concern to delay the landing. The latest mission of Columbia has been plagued by computer problems and the loss of a $400 million satellite.
Bad weather forced cancellation of any landing at Florida's Kennedy Space Center today. NASA nixed a backup landing at Edwards Air Force Base in California as well. NASA discovered a failed computer interface aboard the shuttle on Thursday. Agency rules indicate the shuttle should land as soon as possible when such a failure happens. But today NASA says, well, those rules are open to interpretation.
FSW 1 wird voraussichtlich zwischen dem 10. und 13. März auf die Erde stürzen. Wo das genau passieren wird und welche Folgen das haben kann, ist noch nicht abzusehen. Der Satellit ist mit einem Hitzeschild ausgestattet und verglüht womöglich nicht in der Erdatmosphäre. Dann könnte der Flugkörper mit der Wucht einer Bombe auf die Erde aufschlagen. Das Europäische Bodenkontrollzentrum ESOC in Darmstadt vermutet jedoch kaum eine Gefahr.
Bereits 10 Tage nach seinem Start im Oktober 1993 war der 800 bis 900 Kilogramm schwere chinesische Spionagesatellit außer Kontrolle geraten. Seitdem umkreist er die Erde 16 Mal am Tag. Sein Hitzeschild könnte ihn beim Absturz vor dem Verglühen bewahren, allerdings nur, wenn er in einer stabilen Fluglage herunterkommt.
Der Satellit, der kann nicht mehr kontrolliert werden von den chinesischen Raumfahrtbehörden. Er führt eine Taumelbewegung aus und ist eigentlich anzunehmen, dass der Satellit in der Erdatmosphäre verglühen wird.
Sollte der 30.000 Kilometer schnelle Satellit dennoch ganz durch die Erdatmosphäre kommen, könnte er noch durch einen Fallschirm gebremst werden, sofern der Auslösemechanismus noch funktioniert. Erst kurz vor dem Absturz wird man sagen können, wo der Satellit genau herunterkommen wird.
Tracking stations say the spy satellite is traveling at the speed of a bullet. Although it contains no nuclear materials, the satellite would have the impact of a small bomb if it crashes into a city. Experts expect the crash sometime on Tuesday, but say they'll know its final destination only 2 hours before landing. The satellite, which is the size of a small car, failed 10 days after it was launched as part of a Chinese military program. Astronauts aboard the U.S. Space Shuttle Columbia will have an extra day in space. The U.S. Space Agency NASA has waived off a scheduled landing of the Shuttle Columbia in Florida because of bad weather. The alternate site in California was also bypassed, and the landing has been rescheduled for Saturday morning in Florida. Another in a series of computer problems caused enough concern to delay the landing. The 15-day Columbia mission has been plagued by computer problems and the loss of a $400 million satellite.
Trusted to handle the landing, and backup command circuits were modified to handle the job that you're seeing being conducted right now. With 3 backup computers in place, this landing should be a piece of cake for Alan. He's been practicing on a laptop computer on board for the past, more than the past week. But we'll keep watching as he makes this final turn and prepares to bring Columbia in on time. Temperature is 42 degrees at the landing strip in Florida. CNN's Paul Caron is standing by there. Paul, what does it look like? Can you see it?
John, we saw it just a few moments ago, right before the 2 final sonic booms as it came overhead, and it's now lost a bit in the cloud as far as the naked eye can see as it's making that right turn, approaching the landing strip. NASA gets a big break of the weather here right now. We're under sunny skies and partly cloudy weather. It will be landing into a bit of a face of a wind, and the winds have reached gusts of about 30 miles an hour out here approximately, but still it is a safe landing criteria for this shuttle mission to end, John.
All right. The oldest member of the shuttle fleet has been in space 19 times, including this one. In the past 15 days, 17 hours, and a few minutes, it has traveled around the world 252 times. That's a distance of more than 6.5 million miles. Okay, it's about a minute to touchdown. What we'll do is listen in to NASA commentator Rob Navius, who is on duty at the Johnson Space Center in Texas. And after the shuttle touches down, there'll be some congratulatory remarks for the astronaut crew from both Florida and from Texas. About 45 seconds away from landing, the shuttle has been steered virtually perfectly from what we can tell and what we've heard from NASA during this final few seconds of its flight. Let's listen in to the final few seconds and hear what we hear as the shuttle comes in for a landing at the Kennedy Space Center. You can see it now on its final approach. Wheels should come down any second.
Flare up the orbiter's nose. Landing gear now beginning to be deployed by pilot Scott Horowitz. Main gear touchdown. Horowitz now preparing to deploy the drag chute. No Nose gear touchdown. Columbia now rolling out on runway 33 at the Kennedy Space Center to wrap up a 6.5 million mile microgravity research mission.
There you see it. The drag chute came out as it was supposed to, the shuttle rolling to a stop. And you can see a landing team there at the end of the runway preparing to meet Columbia. Looks like the crew has more than 5,000 feet of runway left, which if you're a pilot is good news. It's good to have extra runway as you're landing. The next shuttle mission will be a visit by astronauts to the Russian Mir space station. Astronaut Shannon Lucid will be dropped off, along with lots of supplies for the Russian cosmonauts and for astronaut Lucid. She'll be the first U.S. woman to spend a long time in the Russian space station. For Columbia, back into orbit next June or July for a science mission, then to the maintenance shop to add an airlock to the cargo bay. John Holloman, CNN, Washington.
Coming down to Earth, a picture-perfect ending to a not-so-perfect mission. It was a perfect ending to an imperfect mission. After a day's delay, the Space Shuttle Columbia and crew landed a little more than an hour ago at the Kennedy Space Center in Florida. The 16-day voyage was marred by the loss of a tethered science satellite and a landing system failure. The 7-member international crew was in no immediate danger from the ship's problems, but NASA used extreme caution to bring the ship back home as soon as possible. The shuttle Atlantis is scheduled to blast off March 21st for its third flight to the Russian Mir space station.
Die amerikanische Raumfähre Columbia ist vor 3 Stunden auf dem Gelände des Kennedy Space Center in Florida gelandet. Die Landung war wegen schlechten Wetters mehrfach verschoben worden. Zwischendurch hatte die NASA überlegt, die Fähre nach Kalifornien umzuleiten. Der Rücktransport der Columbia nach Florida hätte aber Mehrkosten in Höhe von 1,5 Millionen Mark verursacht. Auch während des Flugs der Fähre war nicht alles nach Plan gelaufen. Der Ausfall eines Computers hätte beinahe den Abbruch des Unternehmens bedeutet. Und bereits zu Beginn der Mission hatte die Columbia einen italienischen Satelliten verloren. Das 440 Millionen Mark teure Gerät hatte sich von der Fähre losgerissen und war im Weltraum verschwunden.
Nose gear touchdown.
Shuttle Columbia has a smooth ending to a rough mission.
Allen about to flare up the orbiter's nose. Landing gear now.
It was a perfect ending to an imperfect mission. After a day's delay, the Space Shuttle Columbia and crew landed a little more than an hour ago at the Kennedy Space Center in Florida. The 15-day voyage ran into trouble twice. Once by the loss of a tethered science satellite, then by the failure of a landing system. The 7-member international crew was in no immediate danger from the ship's problems, but NASA used extreme caution and brought the ship back home as soon as possible.
Columbia ist wieder sicher auf dem Gelände des Kennedy-Raumfahrtzentrums gelandet. Damit fand die 16-tägige Mission ein erfolgreiches Ende. Wegen des schlechten Wetters und einer Computerpanne hatte sich die Landung um einen Tag verzögert. Mit Spannung wird nun die Auswertung der Versuche erwartet. Das Hauptexperiment allerdings war missglückt. Ein ausgesetzter italienischer Fesselsatellit riss sich los. Der 154 Millionen Dollar teure Flugkörper ging verloren.
NASA just doesn't send shuttles and probes into space. The agency also makes movies. Some of the images taken by spacecraft are turned into animation that's full of scientific information, and it's also fun to watch. This flyover of the moon was made from images taken by the Clementine spacecraft, which mapped the entire lunar surface in 1994. Scientists and artists at NASA's Goddard Space Flight Center put together the animation. The height of the features on the surface is exaggerated 7 times in this video to allow closer study. Or how about this one, a collaboration between the folks at Goddard and the University of Illinois at Chicago. It combines images from satellites and other spacecraft with data from land and underwater surveys into a video which shows how much of the Earth is actually ocean and what a variety of natural wonders lie beneath the sea. Again, the height of the features is exaggerated. That whole animation is made up of about 3,300 frames. That's enough to fill more than a gigabyte of computer memory.
Beziehungsweise morgen früh zwischen 1 Uhr und 9 Uhr mitteleuropäischer Zeit in die Erdatmosphäre eintreten und dabei voraussichtlich verglühen. Das meldet das Europäische Bodenkontrollzentrum ESOC. Für Europa bestünde keine Gefahr mehr, da es nicht mehr auf der Bahn des Raumflugkörpers liege.
A wayward Chinese spy satellite is expected to come crashing down to Earth very soon. Some British experts think it will probably land harmlessly in the southern oceans on Tuesday. But there is a chance it could hit land, possibly here in Britain. Lawrence McGuinty has the story.
Astronomer Russell Eberst has spent a lifetime looking at heavenly bodies. Now retired, he's enjoyed the last 3 years tracking the errant Chinese spy satellite, which went out of control only days after it was launched.
The average satellite is much higher and is much easier to see because it always comes near enough on time. But this one, because it plunges into the atmosphere, can come early or late by several minutes, and therefore it's much more of a challenge, which is what I enjoy.
Observers at Britain's nuclear attack early warning station at Fylingdales are also watching the tumbling satellite. It's less than 100 miles up, and friction from the atmosphere is slowing it down all the time. It's expected the satellite will cross Scotland near Glasgow at about 6:50 tonight. On the next orbit, it will be over Inverness at about 8:20. An hour and a half later, it's over Dublin and London. Calculations show the risk of it hitting Britain is small.
There have been some estimates between 1 in 500 and 1 in 1,000 probability, but also you should qualify that by saying that the UK, if you look at it from the air, is covered in trees and grass.
The satellite probably won't burn up because it has a heat shield made of oak to protect spy film inside, and its parachute probably won't open because the battery's flat. Lawrence McGuinty, ITN.
Unser Reporter Ralf Benke steht jetzt im Operationszentrum der Europäischen Raumfahrtorganisation ESOC in Darmstadt. Ralf, weiß man dort schon genauer, ob und wem durch den Satellitenabsturz Gefahr drohen kann?
Ja, man muss es leider sagen, es droht wohl für einige doch noch im Augenblick Gefahr. Man hat errechnet, es gibt ein gewisses Zeitfenster, in dem der Satellit auf die Erde fallen wird. Und das ist 1:15 Uhr heute Nacht bis 8:50 Uhr am Morgen. Und man hat genauso errechnet, dass in dieser Zeit keine Bahn des Satelliten über Europa und auch keine über Westasien führt. Das heißt aber, alle anderen Kontinente, sind möglicherweise davon betroffen. Da fliegt der Satellit auf jeden Fall noch drüber. Wir sind hier im Kontrollzentrum der ESA in Darmstadt und hier werden die ganzen ESA-Satelliten kontrolliert, aber auch andere Himmelskörper. Wir sehen dort hinten, es gibt also quasi tausende Himmelskörper, mittlerweile auch ausgebrannte Raketenstufen und allerlei anderes. Und das muss natürlich deswegen kontrolliert werden, weil es darf ja nicht unkontrolliert auf die Erde fallen. Zu dem chinesischen Satelliten, der jetzt abstürzen wird, man weiß, dass er am 8. Oktober 1993 gestartet wurde. Er heißt Fanhuishi Weixing 1, ist ein Spionagesatellit und schon kurz nach dem Start gab es damals eine Panne. Der Satellit geriet außer Kontrolle. Hier ist eine Computeranimation dessen, was jetzt passieren wird. Der Satellit hat in den vergangenen 2,5 Jahren ständig an Höhe verloren, doch kaum an Geschwindigkeit. Mit etwa 29.000 Stundenkilometern fällt er in die Atmosphäre zurück. Dabei erhitzt er sich durch die Luftreibung so stark, dass er auseinanderbricht. Es kann sein, dass er weitgehend verglüht. Wahrscheinlich aber ist, dass mehrere große Teile, die durch ein Hitzeschild geschützt sind, auf die Erde niederfallen. Nun, das Ganze wurde natürlich hier berechnet. Bei mir steht jetzt Walter Fluri von der ESA. Herr Fluri, wie hat man solche Berechnungen überhaupt angestellt?
Ja gut, wir haben mathematische Modelle, die die Bahn beschreiben. Wir benutzen aber auch Radarbeobachtungen vom amerikanischen Weltraumüberwachungsdienst wie auch vom russischen.
Und was kann man über die aktuelle Fluglage sagen? Wie stabil ist die noch?
Ja, die Bahn ist eigentlich stabil, die ist sehr niedrig auf der Erde und der Satellit, der taumelt auf der Bahn. Die Fluglage ist nicht stabil.
Vielen Dank soweit. Das heißt also, man wird jetzt doch noch ein paar Stunden abwarten müssen, wie viele Teile des Satelliten auf die Erde niederfallen. Wir haben hier ein kleines Teil eines anderen Satelliten, das mal auf die Erde gefallen ist. Es ist ein Solarpanel. Damit wird Energie gewonnen im All für den Satelliten. Ja, sowas ist so leicht, das würde sicherlich nicht auf die Erde kommen. Das würde verglühen im All. In der Erdatmosphäre allerdings muss man damit rechnen, dass vielleicht einige 100 Kilogramm doch den Durchgang durch die Atmosphäre schaffen. Wahrscheinlich der Treibstofftank und wahrscheinlich auch der Hitzeschild. Doch ungefähr 75% Wahrscheinlichkeit gibt es dafür, dass das Ganze dennoch ins Meer fällt.
Wollen wir es hoffen. Soweit unser Reporter Ralf Benke aus Darmstadt. Vielen Dank.
2 days after takeoff in 1993, the Chinese satellite broke into 8 pieces, which became tips.
7 pieces, including the main satellite, have already fallen through the Earth's atmosphere into ocean waters. The last and largest piece, capsule 22870, has taken almost 3 years to give way to the Earth's gravitational pull.
Most of the orbital path, as you can see, is over water and instead of landmass. And this is pretty much how we go about tracking objects in space.
About 100 man-made objects fall from orbit every year. The U.S. Space Command tracks and catalogs every one.
For the most part, we believe most items, most objects will burn up during re-entry. However, some of the larger ones will in fact survive, as we saw with Skylab.
Since 70% of Earth is water, odds are any object will land in water. But in 1978, debris from a Soviet satellite fell across northern Canada. In July of 1979, remnants of NASA's Skylab fell over Australia.
I understand that the only problem they had was a herd of horses was scared out of the barn because the objects made such a loud noise.
It's the Space Command's job to track the objects and to notify any country that may be in the path of objects falling from space. Ann Callan, CNN reporting.
We're joined now by Philip Clark, a freelance writer and consultant on space. He's been studying Chinese and Russian satellites for 20 years. Philip, welcome. First of all, in this technological age, we're very used to knowing when something is going to happen. It could be any time from tonight or in the next 2 days. Why the variance in time?
The problem is that predicting when any object's going to come out of orbit is far more of an art than an exact science. The closer we get to the time of re-entry, the more accurately we can pinpoint the time and the place of re-entry. But we simply don't know enough about the upper atmosphere, the orientation of the satellite compared with its trajectory, to be able to predict exactly when it's going to fall out of orbit.
And for the uninitiated like myself, we're told that it's important, the angle of entry is what's really going to determine when and how it will land and where.
Yes, depending on how steep it comes in will depend on whether it's going to burn or survive to the Earth's surface. If it comes in too steeply, then it will burn up because of the friction of the air against the satellite. If it comes in at just the right angle, then there is a chance that the satellite will position itself as it should have done when re-entry was planned in 1993 and start what it thinks is a perfectly normal re-entry procedure. If the systems on board the satellite work automatically, then the parachutes could open and it could come down in somebody's backyard. On the other hand, if everything relies upon electrical batteries, then they will be long dead and the satellite could simply crash to the Earth.
Now, what went wrong in 1993? And when it did go wrong, the satellite was designed to actually crash down into the Earth. Do we know what happened?
We know roughly what happened. The satellite was designed to stay in orbit for 8 days, and then the forward part of it was going to land inside China with photographs and other trinkets that were carried into orbit. Unfortunately, when the time came for the retrofire to take place, the satellite was pointing in the wrong direction. So instead of coming back down over China, it was boosted into a far higher orbit, reaching out to 3,000 kilometres. And as a result, instead of coming down after 8 days, it's taken nearly 18 months to come, it's taken nearly 2.5 years to come down.
Now, when it comes down, in whatever territory it lands, does it belong to the Chinese or the country or the sea area in which it lands?
It belongs to the Chinese under international law. If it comes down intact, then wherever it lands, the satellite cannot be tampered with. It has to be returned intact to the Chinese, and the Chinese will pay whatever compensation or other costs are due.
Now, NASA has said there's something like 7,000 objects in the lower orbit, the atmosphere. What are these objects?
Most of them are dead satellites and discarded rocket stages, other pieces of debris like camera covers, that kind of thing. Plus, you've got the larger structures like the Russian Mir space station complex, or when it's in orbit, you've got the US space shuttle, plenty of communication satellites chugging around in orbit. So there's a lot of stuff up there doing useful work, but perhaps 7/8 of the stuff that's up there is just dead junk.
And what's going to happen to it? Eventually it's going to come crashing down like this satellite?
It's going to come down, but bear in mind that each week we have perhaps 2 or 3 payloads or rocket bodies re-entering the Earth's atmosphere and burning up, and nobody takes any notice of them whatsoever.
Yeah, but the problem with this satellite, particular satellite, it's so large that when it hits the ground, if it hits the ground, it'll be at a speed of 400 miles an hour.
It's not really the fact that the satellite's size that's important here. The important factor is that it was designed to be recovered. Therefore, it's got a heat shield on it, which means that, in theory, it could automatically go into the recovery mode. We don't know whether that's going to happen or not. If it wasn't for the heat shield, then the satellite would simply burn up like every other piece of space junk normally does.
And what do scientists hope to learn from all this?
Quite honestly, I don't think there's anything that can be learnt from this failure. The Chinese have already gone on to a new generation of their FSW satellites, which have had 2 successful flights. So already they've gone on to an improved technology. It would be nice, I suppose, from a Western point of view, to be able to open the satellite and look at the film that's inside, but as I said earlier, under international law, you can't do that. You've got to leave the satellite intact.
And I also gather that on board there is a diamond-encrusted button of Mao Zedong.
Yes, that's right. I'm not sure why it's up there. I think it's just a trinket that if the satellite had been recovered in 1993, it would either have been put on display or possibly put up for auction to try and get Western currency into China.
And can we expect this kind of thing to happen again in the near future?
Oh, yes. Given enough time, this will repeat. Satellites have come down out of control before, as the film has just said. The American Skylab space station, we've had Russian space stations falling out of the sky at the end of their missions. So these things happen regularly, and as long as we're launching things into space, we are going to have accidents which mean that things are going to come down out of control.
And in Britain here, actually, insurers have said that if you have full comprehensive insurance on your car and it lands on your car, you will be covered, but not if you have third party. So
I wouldn't know about that, but the chances of it coming down over Britain are extremely small indeed.
All right, we hope so. Anyway, thank you very much, Philip.
Spokesman for the U.S. Space Command says that if the satellite parts did not burn up, they are likely to have splashed down in the southern Atlantic Ocean. The satellite was launched in 1993, and experts say it was part of a military program. But 10 days after the launch, the satellite was propelled into an uncontrollable orbit due to malfunctioning rockets.
Chinesischer Spionagesatellit ist beim Eintritt in die Erdatmosphäre verglüht. Das meldet das europäische Bodenkontrollzentrum ESOC in Darmstadt. Falls nicht alle Teile verbrannt sind, seien sie mit großer Wahrscheinlichkeit ins Meer gefallen, hieß es. Der Raumflugkörper war im Südatlantik zwischen Afrika und Südamerika in die Erdatmosphäre eingedrungen. China hatte den Flugkörper, 2,5 Jahre zuvor gestartet. Bereits nach kurzer Zeit war der Kontakt zur chinesischen Bodenkontrolle abgerissen. Der Satellit verlor seither ständig an Höhe.
Der chinesische Satellit ist am frühen Morgen über dem südlichen Atlantik in die Erdatmosphäre eingedrungen und dabei höchstwahrscheinlich verglüht. Das Europäische Zentrum für Weltraumforschung in Darmstadt teilte mit, falls nicht alle Teilstücke verbrannt seien, dürften sie ins Meer gestürzt sein. Der chinesische Satellit war vor 2,5 Jahren wegen eines Startfehlers in einer zu hohen Umlaufbahn außer Kontrolle geraten.
FSW-1 ist heute Morgen über dem Meer zwischen Afrika und Südamerika abgestürzt. Das meldet die US-Weltraumbehörde in Colorado Springs. Der Flugkörper war kurz nach 5 Uhr in die Erdatmosphäre eingetreten. Ob der Satellit dabei vollständig verglühte oder in kleinere Teile zerbrach, ist unklar. Experten hatten befürchtet, der 650 Kilogramm schwere Satellit mit den Ausmaßen eines Kleinwagens könne auf bewohntes Gebiet stürzen.
Wo ist er genau? Heute Morgen stürzte der chinesische Spionagesatellit FSW-1 auf die Erde. Seine Reste platschten vermutlich irgendwo in den Südatlantik. Der größte Teil verglühte in der Atmosphäre. Reines Glück, denn es hätte auch anders kommen können. Bernd Raschke über den Schrottplatz Weltraum.
FSW-1, so groß wie ein PKW. Um 5:05 Uhr endete sein Irrflug im Atlantik, irgendwo zwischen Afrika und Südamerika. Kurz zuvor verschwand er von den Radarschirmen der Weltraumbeobachter. Allerdings verglühte der 2 Tonnen schwere Satellit nicht komplett.
Nach einem Sprecher des US Space Command sind allerdings einige Fragmente auf die Meeresoberfläche runtergekommen.
In den vergangenen Wochen häuften sich die Anrufe bei der ESA in Darmstadt. Besorgte Bürger, sie hatten Angst. Rund 8000 Objekte schwirren derzeit um die Erde. Dazu kommt der Schrott, den Weltraummissionen hinterlassen. Flugkörper, die mehr sich selbst als die Menschen gefährden. Angeblich hat der FSW-1 teuren Schmuck an Bord. Ein Fall für Schatzsucher. Die haben auch schon bei der ESA angerufen.
Der außer Kontrolle geratene chinesische Satellit FSV-1 verglühte, ohne Schaden anzurichten. Gegen 5 Uhr früh unserer Zeit trat er in die dichteren Schichten der Atmosphäre ein. Dabei zerstört eine enorme Reibungshitze den etwa 650 Kilo schweren Satelliten. Über dem Atlantischen Ozean zwischen Südamerika und dem Süden Afrikas verschwand er dann von den Radarschirmen. Unser Wettersatellit allerdings ist noch intakt. Er funkt, dass die Kälte noch nicht weichen will.
Bis zum Schluss war befürchtet worden, dass der Koloss auf bewohntem Gebiet aufschlagen könnte. Doch frühmorgens stürzten die Reste des Metallriesen dann weit ab jeder Zivilisation ins Meer.
Die Erde hat ihn wieder. Nach 2,5 Jahren im All ist der chinesische Aufklärungssatellit Fanhui Shiweishing 1 für immer von den Radarschirmen verschwunden. Wochenlang hatte man im europäischen Satellitenkontrollzentrum der Weltraumagentur ESA in Darmstadt die Rückkehr des kommunistischen Himmelstürmers verfolgt. Irgendwo zwischen Afrika und Südamerika stürzten in aller Frühe seine rauchenden Trümmer in den Atlantik. Alle Ängste waren unbegründet.
Seit fast 40 Jahren Raumfahrt ist mir also kein Fall bekannt, wo irgendjemand auf dem Erdboden durch herabfallende Satellitentrümmer zu Schaden gekommen ist.
30.000 Kilometer schnell war der Satellit in der Erdatmosphäre vermutlich trotz Hitzeschild verglüht. An Bord Filme, eine diamantbesetzte Mao-Plakette und eine Buddha-Figur. Laut Plan hätte er Städte fotografieren und wieder in China landen sollen. Doch der 600-Kilo-Koloss geriet außer Kontrolle.
Der chinesische Satellit stellt keine Bedrohung mehr dar. Entwarnung geben können die Wissenschaftler dennoch nicht. Jede Woche stürzen 2 bis 3 künstliche Himmelskörper zur Erde zurück.
Mit 7000 Satelliten und Raketentrümmern ist die Umlaufbahn längst ein gefährlicher galaktischer Schrottplatz geworden.
Im Europäischen Raumfahrtzentrum von Kourou ist die Trägerrakete Ariane gestartet. Schon nach 20 Minuten Flugzeit hatte sie ihre Mission erfolgreich beendet und den Fernmeldesatelliten Intelsat 707 in seiner Umlaufbahn ausgesetzt. Der ursprünglich für den 2. März geplante Start musste wegen technischer Probleme zweimal verschoben werden.
Well, it wasn't a comet, but another object hurtling through space got some attention last week as it approached Earth. It was a Chinese reconnaissance satellite which misfired and failed not long after it was launched in 1993. Agencies around the world tracked its flight and knew it would return to Earth this month, but no one knew where. Late Monday, it hit the Earth's atmosphere and disappeared off radar screens. The U.S. Space Command says if the satellite survived re-entry, it apparently fell somewhere in the southern Atlantic Ocean.
Positioning device, heat sensor, telemetry, payload, all systems go. Into the garbage can, which, aided by a strong back, simulates the stresses of space travel. Acceleration's G-forces, flight's vibration, and separation's sudden shock. 3. Stanford University graduate spacecraft design students show their desktop satellites have the right stuff. Systems that work in harmony, and well enough to survive the garbage can simulator.
If the satellite is built correctly, it should work afterwards and should not break apart. That's the whole thing. If they've got to learn now that once you launch something into space, you don't go up and fix it.
But Alessandro Zago couldn't just stand by as his satellite fell hard to Earth. Zago's satellite not only survived a second drop, but performed as designed. These future aerospace engineers learned something else about design. A little pizzazz helps sell.
This is more than a fun project. It's rocket science. The students' satellites either fly and survive, or the students' grades crash.
The other 2 things we've got on board are a digital camera. We'll be just trying to take pictures of the Earth with it. And then this voice synthesizer.
Having mastered plywood and foam, students move on to the honeycomb, space glue, and computer circuits of real satellites.
The hurdles that we have to overcome to make the actual satellite that they built is to have them be innovative and not think like the present aerospace industry that takes lots of money to do things.
2 years ago, grad students began building an actual satellite they hope to send up on a Russian booster in June. Still another student microsatellite will launch so-called picosatellites. The final form of this one will measure the Earth's magnetic field from space. Professor Twigg says tomorrow's satellites will be smaller, faster, and cheaper, and he expects his students will be building them. Don Knapp, CNN, Stanford, California.
The Shuttle Columbia released the satellite, you may recall, February 25th, attached on a 20-kilometer cord. But the cord broke, and the Italian-built satellite floated off into orbit. Re-entry was somewhere between Northeast Africa and Southwest Asia, but there are no reports by witnesses or evidence that any of the satellites survived the extreme heat.
Der Rücksturz auf die Erde, ein beliebtes Horrorszenario für die Boulevardpresse. Aber der chinesische Himmelsspion ist völlig unspektakulär irgendwo im Atlantik verschwunden. Die eigentliche Gefahr durch die Raumfahrt droht nicht hier auf der Erde, sondern im Orbit selbst durch Weltraummüll. 7.860 große Objekte umkreisen zurzeit die Erde, 70% Schrott. Darunter 2.247 ausgediente Satelliten, die manövrierunfähig durch den Weltraum rasen. Dieser Müll ist registriert und wird beim Start neuer Satelliten in die Umlaufbahn einkalkuliert. Völlig außer Kontrolle sind mehr als 100.000 ziemlich unbekannte Flugobjekte. Die eigentliche Gefahr im Weltraum, diese trudelnden Kleintrümmer. Ein Zusammenstoß mit einer Raumfähre oder einem Satelliten hätte katastrophale Folgen. Thomas Fuhrmann berichtet.
Jeder Raketenstart vergrößert das Risiko. Künstlicher, von Menschenhand produzierter Müll landet im Weltall, gefährdet die Raumfahrt. Abgesprengte Raketenteile, ausgediente Satelliten, Schrottwolken. Seit dem ersten Sputnik-Start 1957 hat es die Menschheit problemlos geschafft, auch das All zu verschmutzen. Wie in dieser Animation der Europäischen Raumfahrtagentur ESA dargestellt, sausen allein im erdnahen Weltraum Tausende von Schrottteilen herum und es werden immer mehr.
Wenn wir die Raumfahrt so weiter betreiben wie bisher, wir nennen das im internationalen Bereich Business as usual, dann kommt es zu einer Krise, einer richtigen Weltraummüllkrise, kann man sagen.
Der Müll kann die hunderte Millionen Mark teuren Satelliten im All beschädigen. Deshalb werden, wie hier in der Nähe von Bonn, die großen Müllteile per Radar weltweit erfasst. Rund 8.000 Objekte sind momentan katalogisiert, ihre Umlaufbahnen genau bekannt. Zuletzt musste im Januar die amerikanische Raumfähre im Flug korrigieren, um einem alten eigenen Satelliten auszuweichen. Viel problematischer und gefährlicher ist aber der nicht erfassbare Kleinmüll. Geborstene Raketenstufen oder abgerissene Schrauben rasen mit enorm hohen Geschwindigkeiten durchs All. Wann dieser auf 100.000 Objekte geschätzte Kleinschrott wo ist, kann niemand vorhersagen.
Falls es zu einer Kollision kommt, von einem 10 cm großen Teil, zum Beispiel mit der Raumfähre, das könnte das fatale Folgen haben.
Was würde dann passieren?
Ja, es könnte zum Beispiel nicht, wenn der Teil getroffen wird, wo zum Beispiel die Astronauten drin sind, nicht, dann würde die Atmosphäre entweichen. Nicht? Also, oder es könnten irgendwelche lebenswichtigen Teile oder Systeme der Raumfähre getroffen werden.
Das wäre lebensbedrohlich für die Astronauten?
Und das wäre lebensbedrohlich, ja.
Völlig ungeschützt sind die Astronauten dagegen bei ihren Raumausflügen. Schon eine 1 cm große Schraube könnte den Raumanzug mit der Wucht einer Handgranate zerfetzen. Die Objekte fliegen mit rund 28.000 Stundenkilometern durchs All. Dieses Szenario ist bisher noch nicht eingetreten, Satelliten sind aber schon beschädigt worden. Mehrfach mussten am amerikanischen Space Shuttle Scheiben ausgewechselt werden und als am Weltraumteleskop Hubble Anfang der 90er Jahre Solargeneratoren ausgewechselt wurden, stellten die Wissenschaftler an zahlreichen Solarzellen Durchschüsse fest. Auf das gestiegene Risiko haben die Raumfahrtnationen mit ersten zaghaften Schritten reagiert. Bemannte Raumfähren erhalten seit kurzem zusätzliche Schutzschilder. Das Hauptproblem aber bleibt. Der schon produzierte Müll ist nicht einsammelbar, es geht nur darum, keinen neuen zu produzieren. Jede Neuentwicklung kostet aber Geld und zusätzliche Ausgaben scheut jeder in der Milliardenbranche Raumfahrt. Ein Beispiel: Resttreibstoff in Raketen war bisher häufig der Grund für Explosionen. Europäer und Amerikaner lassen den Treibstoff jetzt ab, weltweit noch lange nicht die Regel.
Es könnte mehr getan werden. Nicht? Wissen Sie, dieses Problem, das ist ja eigentlich erst seit einigen Jahren ist man sich dessen bewusst, dass da ein langfristiges Problem ist. Und jetzt ist man dran, die Maßnahmen einzuleiten. Es könnte selbstverständlich mehr getan werden.
Dringend fordern Experten, Satelliten so zu konstruieren, dass sie am Ende ihrer Lebenszeit nicht mehr nutzlos durchs All schwirren, sondern zurückgeholt oder auf ungenutzten Umlaufbahnen geparkt werden können. Technisch ist das schon heute möglich, aber auch das kostet Geld.
Sie haben recht, dadurch entsteht also international ein Wettbewerbsfeld. Und jeder, der Geld für irgendeine solche Maßnahme, etwa der Umwelterhaltung ausgibt, der würde seine eigene Mission damit belasten.
Bei den Ariane 4 Raketen rühmen die Europäer ihre Vorreiterrolle in der Müllvermeidung. Unkontrollierte Explosionen sind ausgeschlossen. Bei der Weiterentwicklung der Ariane 5 bleibt dieser Standard erhalten. Zukunftsweisend ist diese Rakete, die im Mai das erste Mal starten soll, aber auch nicht. Sie kreist nach ihrer Verwendung für mindestens 1000 Jahre im All als Müll.
Umweltschutz im Weltraum ist ganz besonders teuer. Und deshalb muss wohl erst eine Katastrophe passieren, bis was passiert.
New details are coming to light about the extent of damage caused by a rocket accident in China last month. On Saturday, Israeli television aired this amateur video of a village devastated by the rocket. The video was taken by an Israeli businessman one day after the accident. Shortly after takeoff, the rocket veered off course and nosedived into the village. At the time, Chinese authorities reported 6 people had been killed, but the Israeli who videotaped the damage says many more may have died.
The tethered satellite launched from the space shuttle in February, which accidentally broke loose and floated away. In a report out this week, NASA says the cause of the problem was debris that damaged insulation on the 12-mile-long tether, causing a short circuit that burned the cable. It's not clear whether the debris was metal left over from the manufacturing process or dirt picked up on board the shuttle. The experiment was designed to find out whether useful electricity could be generated by the tether and satellite sweeping through space.
The Kennedy Space Center launch team is proceeding with plans to launch the Space Shuttle Columbia, scheduled for liftoff at 3:18 p.m. This is Shuttle Launch Control at T-minus 3 hours and holding, and we do have live television of our flight crew on the 3rd floor of the operations checkout building, just departing their suit-up room and making their way toward the elevator, which will take them to the base of the room. There is a wide range of interest on this mission and its international crew. Workers at Kennedy Space Center, of course, are all anxious to see this one go on time today. And the commander, Andy Allen, has emerged from the building, followed by his pilot, Scott Horowitz, and payload commander Franklin Chang Diaz, mission specialist Jeffrey Hoffman, mission specialist Claude McCoyer, Mauricio Kelly, and payload specialist Umberto Guidoni. Everything continues to go well as the launch team works to finalize all aspects of preparations for the launch of Space Shuttle Columbia at 3:18 p.m. Eastern Time. At this time, the booster test conductor is verifying that the chamber pressures in the solid rocket motors is at the appropriate levels. Also, air-to-ground voice checks have been completed between the crew and mission managers here in the firing room, and the crew cabin closeouts are about to begin. All checks of the payload's instruments have been completed, and engineers and managers are reporting no technical concerns.
OTC, CDR, I'm going to move my seat. I copy CDR.
Currently at the pad and here in the firing room, all continues to go on schedule for the launch of Space Shuttle Columbia this afternoon at 3:18. At T-minus 1 hour, 27 minutes and counting, this is Shuttle Launch Control. We are continuing with the count.
20 minutes to pick up the plane. I copy. CLS is go for orbiter access arm retract.
The orbiter access arm is now being retracted away from the vehicle. This is the walkway used by the crew to gain entry into and out of the vehicle, and it can be returned to position within seconds if need be. T-minus 2 minutes, 30 seconds, and counting. And the gaseous oxygen vent hood is slowly being retracted away from the top of the external tank. We are transferring to orbital internal power at this time. Columbia is now running off its 3 main onboard fuel cells. Coming up for a go for auto sequence start.
Go for auto sequence.
And we have a go for auto sequence start. Columbia's onboard computers have primary control of all the vehicle's critical functions. T-minus 20 seconds. T-minus 15 seconds. T-minus 12, 11, 10, 9, 8, 7. We have a go for main engine. 5, 4, 3, 2, 1. And we have liftoff of the Space Shuttle Columbia, continuing space research through tethered satellite technology.
Roger roll, Columbia. Houston now controlling. Columbia rolling on course for a 28.5 degree inclination orbit.
Gauge showing 45% on the left.
Roger, stand by.
We're shifted up. Okay, Houston, we copy that. It's just our bias on the TC gauge.
And Columbia, you're go at throttle up.
Go at throttle up.
3 engines on board now back at full throttle. The crew reporting a errant gauge on board. However, all indications for the engines are that they're operating well. Again, back at full throttle. Altitude now 69,000 feet. Downrange from the launch pad, 8 nautical miles. Columbia already traveling 2,000 miles per hour. Flight controllers standing by at 2 minutes after launch for burnout and jettison of the twin solid rockets. Booster officer confirms a good separation of the twin solid rockets. Columbia now on its second stage main engines. 3 main engines again operating well at full throttle. Columbia, performance nominal.
Copy, nominal performance.
Okay, GC. Roger. Okay, Inco, your commanding's complete, correct?
For now, but we got commands in about 5 or so.
Okay, GC, let's go ahead and sync the system. All flight controllers coming around the room for a go, no-go per the LCC. Prop, go. GNC, go. Guidance, go. FIDO, go.
I'll come back to you, GC. DPS. We're go. Payloads.
Go.
Eagle. We're go. Econ. We're go. FAO. Go. INCO. Go. Max. Go. Booster. Go. Sergeant.
Go.
Okay, all flight controllers, if you're still go, green please on your status lights. GC, let's unsafe the mod. NTD Houston flight.
Go flight.
Yes, sir. The dump data, we just had a chance to look at it. It is the same signature we saw earlier this morning. And with that confirmation, we are go.
I copy that. Launch director, NTD. I copy that. Ops manager, you ready? Jim, we're cleared, and you're cleared to launch. 10. Yeah, let's just go for maintenance and start. Liftoff confirmed.
Copy.
Houston, Columbia, we're on a roll.
Flight guidance, we see a good roll.
And left command.
Roger, roll, Columbia. Booster flight. Go flight. Command message.
And Houston, our gauge is showing 45% on the left.
We got good data, flight. It's Roger, stand by. Copy. Showing left engine at 104.
We're showing good output.
Columbia, we're showing good engines, good commands at all three. Throttling down, flight, good commands at
Okay,
left.
thank you much.
Copy. Miko confirmed. Copy. Stand by, Fido.
Flight final nominal Miko, no OMS 1 required, and go for the photo DTO.
Copy, and prop. Prop scoop. Raj, Capcom.
Columbia, nominal Miko, OMS 1 not required.
TSS.
You have a go for the photo DTO. Good job, guys.
Okay, I'm Brian. Thanks so much for everything. We're happy to be here.
Yeah, Scott was saying it never works that fast in the sim.
Roger.
I don't know if I'm hoping that you could see some of the particulate material that was coming out of the payload bay. There was quite a bit of it, mostly just little white particles as far as we could tell.
Yes, sir, we saw that, Jeff. That's an excellent image you've downlinked. That's just spectacular. What a great Earth Ops attitude you're in. This one's going to go in all the movies.
And Houston, the DDCS activation, steps 2 and 4 of TSS activation are complete now.
Copy, payloads concurs. That's a great view of the glove box.
Okay, Dave, yeah, I'm just setting up everything. Lights, you can see the lights right here, and we got the little internal box already connected. Everything looks good, and I've connected the power. I'm just about ready to power the thing up. Let me read you also some filter numbers, which I think you're supposed to write down. Okay, Houston for TSS, real motor checkout is complete. and I'm sure you see the final outboard temperature is 45.1 rather than greater than 50, but aside from that, everything looks good. And we're ready for the vernier motor checkout.
On board, the crew members are behind in their timeline, just about by 2.5 hours or so after they've spent some time attempting to resolve some issues with a computer referred to as SmartFlex. That's a computer that processes data from the tethered satellite system. Apparently, the one of two cores on that satellite failed. It failed automatically over to the second core, and currently the right core of that SmartFlex computer is being used and appears to be operating as expected. That will allow satellite activation to begin for the tethered satellite system. The crew members also have been working with a second unit called the DDCS. That's a dedicated display unit that graphically displays information about the major components of the tethered satellite system. That unit is functioning, however, it is processing data at a very low level due to a low performance level.
Columbia for TSS. Mandy, we're in the process of reconfiguring for KCA ops. We're going to be uplinking the DDCS timeline files for your one-day late deploy. And I got a procedure to read to someone.
Yeah, copy that and stand by one.
Okay.
Columbia Huntsville for Spree FO1. No response necessary. You have a go for step 10.
Columbia Houston, we'd like you to perform a maneuver for SLA Cal at 05 hours.
Huntsville, Columbia, the set is activated, and we're standing by for your action on page 12-4.
We copy, and we'll be doing that depth reset from the ground shortly.
Okay.
Go for deploy, right?
No, we're no constraint to fly away right now.
Sounds good. DPS?
We're go.
Inco?
We're go.
Okay, Capcom, you're up.
Go.
Surgeon?
Go.
KGC, sounds like good work. Let's make sure we stay that way. Understand. Stand by, Maurizio. Columbia, you are go for satellite attitude verification, 3-14. Go ahead, Maurizio. Columbia, Houston, you are go to unlatch the satellite.
Okay, Dave, welcome aboard and go to unlatch.
So there'll be an attitude at 23.
Okay, very good. I'll do those steps now.
In 2 minutes, there'll be an attitude. TNC concurs.
Okay. You'll be in attitude in 2 minutes.
There's an echo up here.
Now. Columbia, we've verified good flyaway attitude, and 4 Bravo should look right now.
Please, thanks. Thanks.
Okay, all operators, don't get too mesmerized by the TV. We are 20 minutes away from flyaway. Let's keep an eye on what's going on. But it does look nice.
Go.
GNC.
We're go.
Max. Go. Eagle.
Go.
Ecom.
Go.
FAO.
Go.
Payloads.
Go.
DPS.
Go.
Inco.
Go.
Capcom, the crews go for deploy.
Columbia, Houston, you are go for release per performance gate 101.
Copy, go. And things look fine up here.
Things look fine down here, Jeff. We will be uniform through the handover through Milan.
Okay, and we show both sets of thrusters on, and we're looking good.
Concur.
Thrusters and the APS heaters are both on, looking good.
We concur, thrusters and APS heaters on.
We're only about 1 degree out in yaw flight. Everything else is less than 1.
Okay, if you see the crew starting to chase the libration like that, give me a blow-by-blow on that.
Call.
Smooth, we've turned inline 1 off. We're putting the satellite in yaw hold. There's a slight drift towards the orbiter starboard, and Andy's controlling it.
And we copy. And
Copy, we see it, concur.
inline 1 off. Flight confirmed. Good tensions, flight. APS heater off, flight.
Copy.
Okay, we see the tension go way down, but the tether's still going out fine. Very slight lateral oscillations, but it's looking real good.
Copy, flight.
Copy, Jeff, thank you.
Flight GNC.
Go ahead.
Yeah, B10 is configured per the checklist.
Copy, B10.
broken at the boom. The tether has broken. It is going away from us. Get it on the TV, Claude. Please get it on the TV. The tether has broken.
Copy.
Trying to photograph it floating away from us.
And Jeff, we're tracking it with the radar, and we do read zero tension.
Okay, Dave. Looks like all the tether is outside of the boom and well away from the orbiter. We've got some tether inside the boom. Maybe it looks like about 8 or 10 meters. So it broke inside the boom, it seems. We've got the brake on. And we don't see any tether movement. It's just laying inside the boom.
Copy all, Andy. And stand by. Okay, Andy, and we want to completely verify, you have a visual on the satellite and the tether is moving away from the shuttle. I'd like some words on that.
Okay, well, we had a visual on the satellite up until we got into darkness here. We'll go ahead and try to pick it back up. But at the time that we had it, all the tether was heading up towards the satellite and was well away from us.
Copy.
Dave, it looks like we still have a radar lock, so we could keep that for a little bit, unless you guys are tracking it better than we are.
We have an image.
Okay, and what you're seeing now, we were using the 350. And confirm you are seeing a picture?
Affirmative, Jeff. Good image.
Okay, this is taken through the EOS 350 millimeter lens. We were photographing the shape of the tether, and you can see it just starting to go slack now. Unfortunately, in all the excitement, somebody bumped the camera, and we lost it. Okay, and that's the view that we had of it as it was drifting away, and we got it for a minute or so before sunset.
Yes, sir. Well, those are some tether dynamics we did not want to see.
Well, we have demonstrated that you can generate a lot of electricity with tether, and unfortunately, we've also demonstrated that you can use tethers to launch a satellite into a much higher orbit.
And FIDO concurs, that was one of our objectives. Two of our objectives, at least. In fact, we can see it picked up about an 80-foot-per-second boost.
Without using any propellant. Okay, and there the sun was setting. And I guess we lucked out as far as being able to capture some of it before the sunset.
2 minutes to the ZOE. Back with you on the west at 2206.
Copy.
That's a beautiful shot of an amazing piece of equipment.
We can't send you a birthday cake, but here it is.
That looks very tasty.
Okay.
Thanks for all the well wishes.
3, 2, 1, mark. I think we got a good burn going.
And Maurizio, this one has a higher flow rate, and I guess that's why we've got more eyes on this one.
I see. Okay. And I see you on, you should have the front door view.
And we're still seeing the displays.
Columbia, don't let that thing get loose.
I thought you were thinking exactly the same thing.
If it gets any bigger, we're going to leave you all up there.
Columbia, Houston, we'd like you to perform a maneuver for SLA Cal at 05 hours. That's just in a few minutes.
Roger, maneuver for SLA Cal, 05 hours. We'll do that.
And thanks, Mauricio. We do have live TV into the cabin.
Copy.
Columbia, we're 1+30 from the ZOE. Back with you at 0641. No response required. We're with you on the mid-deck, Franklin. You look real busy.
On my mark now. 3, 2, 1, mark. The igniter is on. Igniter released. Nice flame shooting upwards. Pretty fast burn this time. Okay, and the film just stops on the top camera. Just about on time.
At Columbia, Houston, we're 2 minutes to a teeter LOS. We'll pick you back up at 9 hours, 9 minutes.
Roger.
Hello, Jeff. Hi, Claude. We're looking in the window at you.
Atlantis, Columbia.
Columbia, Atlantis. We have you loud and clear, Andy. How me?
Well, hey, Chili, how you doing? We're just, we're passing Leeville right now. We'll be over top of the Cape in about a minute and a half.
Well, Andy, you all been up there too long. We're missing you down here. When are you coming home?
The Amazon River of Brazil, clearly visible with the sun glint off of the water.
Environmental Systems Officer here in Mission Control reporting very good cooling for the orbiter as it passes now down to the final phase of its entry, less than 11 minutes away from touchdown. This view of Columbia from long-range tracking cameras at the Kennedy Space Center showing a very stable vehicle, now 5.5 minutes from touchdown.
Columbia, we show you on energy approaching the hack. Winds are 330, 15 gusts to 19. That's pretty much all on the head. And no change to altimeter.
Allen about to flare up the orbiter's nose. Landing gear now beginning to be deployed by pilot Scott Horowitz. Main gear touchdown. Horowitz now preparing to deploy the drag chute. Nose gear touchdown. Columbia now rolling out on runway 33 at the Kennedy Space Center to wrap up a 6.5 million mile microgravity research mission.
Good. Houston, Columbia, we'll stop at the Kennedy Space Center.
Roger, we copy your elation. Welcome back, Andy. Great landing, and we'll get you your post-landing delta shortly.
Houston, Columbia, standing by words, hydraulic load test.
Roger. Doc, hydraulic load test not required.
On glide slope on center line.
Copy. Columbia, show you on glide slope on center line.
Roger, Houston, field in sight.
Roger, copy field in sight.
Ground speed enable auto load release.
Copy.
Good. Houston, Columbia, we'll stop at the Kennedy Space Center.
Roger, we copy your elation. Welcome back, Andy. Great landing, and we'll get you your post-landing delta shortly. Okay, Max, any immediate post-landing deltas?
None flight.
Eagle.
None.
Ecom.
None. We'll be going on ammonia real soon here, though. We'll get back with you.
Copy that. Okay, no immediate deltas. Capcom, he's go to pick up with the post-landing procedures. Columbia, Houston, no immediate deltas. You have a go to pick up with your post-landing procedures, page 5-3.